All right, we're on the air. Welcome, everybody. It is February, not February, November, September, October. Yeah, November the 2nd, 2018. And I knew it was one of those cold months. My brain's starting to freeze already, if you can't tell. Um, Welcome to the show. This is the Stunthangar video hangout. I'm Rusty from Stunthangar Control Line Forums. I'll be your host for the next few hours until at least midnight. And if we get lively conversation going, we'll go on until the diehards can't go anymore. And I think the other night we went on past 1 o'clock, did pretty good, had some excellent conversation and some new viewers too. I had one of my buddies from Cox Engine Forum was watching but couldn't get into the text recently. Hoping maybe he's going to give me a call here when we get going. And so if my phone rings, I might get on and help somebody get started. And as a matter of fact, there's a couple of them. My other friend Charlie from Huntersville is where I know him from. Might try to get on with us and is unsure of exactly how to get the computer all shaken down and working right. So if my phone rings for him, I'll pick it up and see if we can get him on too. Hey, Jax Navely, how you doing tonight? And Jack's one of our uh, faithful regular YouTube watchers. We get them on YouTube that just like to watch and use the text box to chat over there, as well as video and microphone uh, visitors in here. And From the Stunthangar Control Line forums, you can go to the at the bench thread and get the link to come in here live. And if you go to the Control Line forums YouTube page, the Stunthangar, two words, Stunthangar, Hangar on YouTube. That's the name of the channel. Then if you get to that homepage, then you'll see me live as we broadcast the show, and you can watch it, and you can scroll backwards or forwards, and scroll it as forward as real time, and you can talk with us as we talk, and in the same time frame we're in, so I can share your conversations. And Night Nav, hey Frank, how you doing tonight? I'm glad to see you in here. Frank's another one of our faithful viewers, and so looks like we got 8 people watching us from the YouTube right now, and hopefully we will have some people joining us in the video and microphone side. And Jack Snavely just gave us a super chat donation, which I appreciate. That is the $sign at the bottom of the chat box on the YouTube watch page. And thanks. That helps pay for the server fees and all the stuff Sparky has to have running. And I get a little bit of that too. So I appreciate that. And all of you that are generous enough, I appreciate it. If you can't donate, we understand. That's fine. You're still welcome. If you don't want to donate, that's fine too. You're just as welcome as everybody else. So everybody, just come on in and hang out. We'll have a good time. Friday night, maybe we, you know, get a little loosened up and have a good conversation in here. We got pretty serious the other night. We had Doran from Atlanta, formerly from Romania, who is doing some extremely sophisticated composite builds on a stunt ship. And he does the same thing with sailplanes too. In fact, my friend and flying buddy Wayne, that y'all hear me talking about frequently, has been following his RC Group's thread where he's building sailplanes and using much higher tech than most of our U.S. built stuff is, and the Europeans really are on target with some superior construction techniques, all composite. Um, Doran's plane has no wood. I think he said it had one piece of wood in it, and I forget where he said that was. But for all practical purposes, he molds and shapes everything so that he can build them once he gets his system straightened out completely. Oh, let's see. I gotta let somebody in. Oh, that's the man I'm talking about right there. In just a second, while I approve you and let you into the room, if it'll let me let you. And as soon as your picture goes bright, you can. It's hard to do. Excuse me. Show and broadcast. I know it's going to let me let you in a second. Show and broadcast. There we go. Okay. And your microphone is on too. How you doing tonight, Doran?
Good, good. I just put my little one to sleep, so.
Ah, okay. Well, you caught me talking about you. Actually, I was talking about all our newer members lately, and I was telling them about your uh, superior composite techniques for assembling not only stunt ships but sailplanes, that sort of thing too. So anyway, I'm glad you could come be with us. You're my first video guest so far. I got a couple of people over on the YouTube side, and hoping a couple of phone calls are going to come in so that I can help some new members who've never been able to visit us get started too.
I see. When is this starting, anyways? What time usually?
8:40. Excuse me, 9:40 p.m.
Nine forty.
9:40 sharp. Yeah, and the I don't post the announcement in the at the bench thread on Stunthangar until I actually go live. So it's not there if you get there at 8:30 at 9:39, but if you get there at 9:40, it should appear, and that way I don't have people coming in early while I'm trying to still get things set up.
Oh, I see. Got it. Oh, that's cool.
So
Yeah, I just didn't know what time usually starts, so that's
that's
all.
it. Yeah, 9:40. I know that's a odd time, not 9:30, not 10 o'clock, but 9:40. But it works for me with my scheduling, and so that's what we do. And
Oh, cool.
that way, everybody's through eating supper and watching TV in the family room where I'm sitting. I'm sitting in the house family room right now, so it's clear, and I'm free to do my show until the wee hours of the morning. So, what'd you do today?
Not much. I just clean up the garage a little bit and put some stuff away. Work, the usual.
Yeah,
Yeah.
yeah. There's that work.
I want to go
Everybody's.
lie, but the weather is just really atrocious here.
Yeah, it was pretty bad here too. It was raining sideways for a while today,
Yeah.
and I think my buddy Wayne's up in North Carolina at a sailplane contest, and they had nothing but wind and rain up there too. But I think they went out and actually got some flights in. But it's in Greenville, North Carolina.
Oh, I see. Yeah. Yeah. Sometimes they fly through some really nasty weather,
Yeah, I
and
don't think they got a lot of lift out there today, but I guess that makes it a good practice day.
you'll
If
be
you
surprised. You'll be surprised some of those top guys how what they can find out in those atrocious days.
yeah.
And I was at the contest when it was so cold outside. I mean, after two rounds, just about everybody decided that they said they had enough, and I said, "Nah, it's not." And I think we were flying three flights, 320. So in a 10-minute window, you need to make three flights, 3 minutes and 20 seconds, and they
Hmm.
were actually making it. And it was windy, it was cold, the lift was nearly unexisting, but but somehow they were making it. I was like,
Yeah.
it's just incredible. I have no words, how they could do it.
Oh,
Is that
let's see.
Sparky?
I've got Sparky to let in here. I've got to approve him and come in, Sparky. I clicked your button. These controls are slow to operate. Come in, Sparky. Okay, let me try
I think
changing
his
one of
mic
my.
is muted.
Yeah, it stays muted till he gets in. These controls are just kind of glitchy. There we go. Okay, you're in now, Sparky. Good evening.
Yeah, what's going on? Pretty slow tonight.
Just me and Doran, we were talking about sailplanes, and we're just kind of kicking the show off, waiting to hit our groove. So, how you doing tonight?
All right. Just getting ready to go back to St. Louis.
Okay. Well, how long you gonna spend in St. Louis? Any time to get some working in your shop there?
No, just a week.
Okay.
So where are you now?
Dayton.
Hmm.
Dayton, Ohio. Yeah.
Is that like a job stuff or?
Yeah.
Ah, cool.
I have a little apartment here and a shop. So I build here and build at home and go travel back and forth.
Hmm. Are you gonna build something this winter or just call it off since you just made your plane just not too long ago?
No, I'll be building another one this year. One a year, at
One.
least. Usually two or three.
I think one is enough. I might go to see Mark pretty soon and build the second plane for myself.
Mark, who?
Mark McKinney.
Hmm. He the one with the molds?
Yeah,
Where does he live?
Illinois, near Chicago in Aurora.
Uh-huh.
Yeah, yeah. I think I'm gonna go there for a week and put together a plane and come back with it. Um, and that's gonna be my main plane for next year.
You gonna
Uh,
paint this one?
in a mold, yeah.
When you're all prepared to start molding, what all raw materials? What all raw materials do you have? You've got resins and hardeners, and then different types of strands of carbon carbon fiber,
Yes,
carbon tow, that sort of thing.
yeah, yeah. You pre-cut and prepare everything before you even start the molding process.
Mhm.
Then once you start to mix up the resin, pretty much you have about 30 minutes to 3/4 of an hour to put the parts in a mold and
Yeah,
vacuum and have it going on, right?
yeah,
So and also part of the preparation is to do the painting.
hmm
So because we are so light, we can afford the paint. And uh, the second plane was at 53 ounces. And what we decided is we said like we really want to try to do the painting in a mold.
Gel
Um,
coat. Gel coat.
no, no, I don't want to do gel coat. Actually, well, we do a two-part paint, but we do a clear coat. What I want to do, I want to have a clear coat and then put my stripes and design and all the stuff with the two colors, basically stripes like I have right now, kind of the same paint job I have right now, and we let it dry overnight, and that's with that the mold is prepped and ready to go, and then next day we just spend like 45 minutes to put everything in a bag. So each half of the wing, each half of the stabilizers take half of the fuselage, half of the nose. Each one takes about 45 minutes. So if you think like that, we have Two half of the wings, that's an hour and a half. Two half of the elevators, that's about another hour. Fuselage again, another hour and a half. So in one day, basically, we pretty much can mold, put everything in a mold, have it ready to go to be joined for the next day. So in day two, we already pretty much we're joining the wing panels, the elevator halves, the wing halves, and the fuselage, both rear section and front section. So with that in mind, on day three, we start to do the prep for the second wing and second elevator.
Mm.
So that means, we put the PVA, the clear coats, the paint, and we cut the materials and stuff like that. Which means this is day three. Day four, we mold those halves, and day five, we join those two halves. At which point, day six, when we take everything out of the mold, we already have a plane. So that's kind of the pace at which we can do it.
Are they aluminum molds?
What?
Are they aluminum molds?
No. The only aluminum mold I have is for the horizontal.
For the what?
For the horizontal. It's aluminum. It's way too expensive to do that.
So what are the molds made out
of? It's a tooling board. Tooling board. It's a material that's made for molding purposes, and usually tooling board it's a material that's made for particular machining. So you machine the parts in a mold, you machine the negative in a tooling board, and you lay your part in there, and that you make your finished part after that.
So you ball milled that all out on a mill? The mold?
Not just a ball nose. It's I used at least 10 tools when I did that mold.
And the mold's about 2 inches thick?
Yes. Yeah. And this tooling board is a very, very hard urethane plastic, actually. And the one I chose, it's already designed for making molds of this kind, and you are able to lay up material inside that mold.
So is that mold CNC'd?
Yes. Yeah. That's how we did everything, because that's the only way to ensure near perfect alignment and repeatability, and that way you can make interchangeable parts as well. Because right now I have the ability to basically, if I make another wing or another whatever, I can take the part off of this plane, put a new one in there, bolt it in, and I'm back in business.
Now you said Mike McHenry?
McKinney.
Mark
McKinney.
Mark McKinney, that sounds familiar.
Yeah, it does too. I just can't picture the plane that he flies.
He was flying an XP-40, a white plane. Looks like a Thunderbolt. He flies in advance, usually.
So when you make your molds, have you got alignment helpers on it, like little tongue and groove pieces or anything that make them fit together exactly in the same way every time?
Yes.
It's called keyed.
It's called what?
It's called keyed.
Oh, okay.
Keyed, or other people can call it registering.
Yeah, yeah, okay.
Yes, it's also. Yeah, I have alignment pins that have like a bullet shape.
Mm-hmm. And then places where you're gonna
kind of look like this.
Yeah. And plus, I guess places where holes need to be drilled for other accessories and that sort of thing too.
Yeah.
So, yeah.
Yes, because you have bolts that go through, and when you close the mold, I have a long bolt that goes all the way through with a nut on the other side, and you just press it together and close the mold.
Yeah.
Yeah, and everything in this plane, it's aligning and fitting within thousandths of an inch
Hmm.
tolerance. I think most I have tolerance over there, it's maybe 3 thousandths of an inch. And the parts that actually assemble the wings, when the wings come together, the tolerance between the pin and the components inside the wing, it's 1/2 of a thousandth of an inch.
Yeah. Let me click on Sparky here. Let's see what you got there.
Oh, that's my,
Dinner.
Did you fix it?
Of course.
Cool.
You can't even tell. I'll show you. I forgot to put this wheel back on this.
So, oh my goodness, look at that. You can't, yeah, you're right. Beautiful job on the repair.
Yeah, that's why I didn't want to put no fiberglass or anything on it.
No, it was going to be something temporary, just for the flight, to fly in the contest. That's it.
Yeah, but if I'd have done that, I could never have repaired it like that.
Ah, okay. Why didn't you fly? Did you have your new plane over there? My best guess, you made it before the contest.
The
Yeah.
high roller.
Is that right, or?
Yeah,
Why didn't you fly the other plane?
not gonna press my luck. I already broke one airplane. Oh. Broke off. Oh well.
Yeah.
Yeah, I just was gonna polish this out. It's been drying for a week now, so I'm ready to polish.
So look at this.
Beautiful.
Oh yeah.
This is a wing panel I made. Give you an idea how the finish on this thing.
Yeah, that's gorgeous.
What is that, a sailplane?
Yes. This is a DLG wing, and you can see the flaps. And it's all hinged in here.
How much does that weigh? Not much.
This is 52 grams, 54 grams. And look at the size of it.
Yeah.
This is about 30-inch in span. And here's this, look at it. It's palm of my hand,
Yeah.
It's about 7 inches, something like that, 7 or 8 inches.
Yeah, something like that. Okay.
7 inches.
Yep.
5 to the hinge line.
Yeah. And the span is
29.5.
29, yeah.
Yeah. So imagine this is an elevator on a control line plane. This weighs 54 grams.
That's 1.5 ounces.
Yeah.
Plus the horn, so that'd be 2.5 ounces. That's right in there.
Yeah. Yeah, but this is solid core. This thing is gonna last forever. It's not gonna bend. It's not gonna do anything. It's just that's what you're getting.
What kind of material is that when you say solid core? What's inside it?
It's a Roja cell core. Roja cell, it's a structural foam, and we use it because of its very, very strong, very stiff material. It weighs about 30 kilograms per cubic meter, which makes it a lot lighter than the lightest balsa wood you can get.
I know you're from somewhere else, but you got to speak English to me. I don't know how much is that in ounces.
Sparky's not metric yet, huh?
I don't know how much is that in ounces, but per cubic foot, I think it's 3 pounds per cubic foot, if not two and change. But the compression strength of that foam, it's over 60 pounds per square inch. So it has a very high compression strength. And it's very stable material. It doesn't warp in time. It doesn't twist in time. It doesn't do any of that. So a lot of people actually in the glider world, this is the only foam they use over there. So I like it because it has a finer grain. And usually when you make a wing like that, what you do, you take the foam and put it on a CNC machine, and you cut the foam on a CNC machine to the exact size.
Hot wire?
No, this is 3D cutting. You cannot do that with a hot wire. Hot wire is good for a section that's like trapezoidal or something like that. Maybe like for example, the wing in your plane. That you can actually cut with 2 templates or something like that. Many times what they used to do in the glider world, they make several panels to get a more of a elliptical shape. But after a while, they walked away from that technology, and they start to cut the cores on a CNC machine, and they do 3D cutting on them. And they cut them. They cut the shape, the top, the bottom of the CNC machine, and what they do is they actually cut it with a twist into the wing too. So if the wing has a washout or something like that, that is built in to the cutter path that you actually use to make the parts. So that's kind of the labor intensive part. And also another part of the labor intensive part is to make the molds. But once you have that, making a wing like this takes 30 minutes or so, if that. Because it's just easy to do. The hard part is putting the upfront work to make templates, to make fixtures for the CNC machine to cut that foam and that takes weeks sometimes. You can do it quickly if you have people that help you, but if you do it by yourself, it takes a little bit longer. So that's, just, yeah. And Rusty, to answer your question, almost most of the layout in this plane is just carbon fiber foam and then fiberglass on the other side.
Yeah.
So we can make it lighter than that. We can go to carbon fiber on the inside as well, and it's going to be a little bit lighter, perhaps much stiffer than it is right now, but it costs a lot of money to do that.
Mm-hmm.
So you are looking at about $120 for a sheet of carbon, which is about what's 3 meters, 6 feet, a little bit over 6 feet by 2 feet wide, 6 by 2. So that's what the piece of material is. So that's at least 120 plus the shipping, because this comes from where is it coming from Ukraine, I think. And a lot of the materials that we use there, almost none of them are local.
Have you tried those Ukrainian lines yet?
What?
Have you tried the
Ukrainian flying lines?
The 4-strand lines?
No.
Well, Hunt's been telling us about 4-strand Ukrainian flying lines that he thinks are far superior as far as no stretch and very low drag.
No, never used them. I heard about them and I saw them, but I never did.
I got two sets. I'm gonna try them.
Let us know what you get. What do you think about it?
The one said is 14,500, and the other said is 16,500.
Mm-hmm. See.
Yeah, Bob's of the impression that they make a huge difference in the flyability of the plane, that it handles a lot better with those lines on it. I'm not sure that at my level I would see as much difference as he does, but
Yeah.
he does.
Yeah.
Well, you need to put rat droppings on top of your wings.
What was that?
You need to put all those rat turds on top of your wings, like Howard Rush does.
Oh, you're talking about those
Turtleate.
yeah,
Why would I do that?
vortex generators.
Exactly.
I mean, why would I do that? I mean, just what do they help with?
He had nothing. You guys seem to think so.
Yeah, I've seen a bunch of people putting them on, but I haven't seen a bunch of people justifying them and saying like, well, this is what they do, this is how they operate,
Well, see,
and
where you have an advantage is your airplane is in the right direction. It's light. They wouldn't need them turtleators if they built a lighter airplane.
We have a question on YouTube about your plane, Doran. Jack Snavely asks, is it possible to go with glow fuel on this material, and will fuel melt it or clean off easily?
Be fine.
Not an issue because I put 2-part clear on it.
So it can't even get to the material, even if you spilled it on it. So
Even if he didn't put that on there, that resin, there's no problem. It's like a prop. You know,
yeah,
it doesn't hurt a prop. The resin's gonna protect it.
Yeah, that epoxy type resin is almost bulletproof to most of the solvents we use.
Yeah, but you need to think about it that it's not exactly non-porous. Okay, it's on a porous surface, and the material itself is porous. But because I put a clear coat in a mold before I do anything, it has a uniform blocker that blocks anything to go through that first layer before it gets to anything else.
Well, if you were going to build one of your airplanes for glow, all you'd have to do is turn it, paint the inside with finishing resin or whatever.
No, I would make since the nose is detachable, I just close that whole area, and I would close the front of the fuselage, so there's no connection in between them. And with that, you can put like a rear exhaust muffler on it, and just like you normally do on any other plane, and that's it.
I'm talking about fuel proofing the inside of that nose, just paint it full of resin.
Oh yeah, obviously, yes. Yeah, the only area you would worry about more than anything else is the nose area. That's about it.
Now, we've been talking in some other shows recently about the difference in architecture of the airframes for electric and for glow. And as far as here, I got to let somebody in. I'll talk while I'm letting them in. As far as balancing and positioning the batteries go, you end up with a little bit different shapes and sizes, and just having a switchable nose might not be quite a one-to-one swap. I'm trying to let you in, Al, but show and broadcast. There we go. You can turn your mic on now, and you should be good. Okay, this is Al from Middlesex Modelers.
Hey, Al.
Hi, how you doing?
We've got Doran from Atlanta in here with us, telling us about his fabrication techniques.
Okay.
But anyway, do you see what I'm saying, Doran? As far as changing one of these, if for instance you had one of these planes and you had two noses, one was for an IC engine and one was for an electric engine, could you make it swap that easily and fly close to the same, or what other things need to be rearranged in order to?
Certainly.
Yeah, yeah, absolutely. But it's so easy to make a fuselage. The thing with electric, you need the cooling to
Mm-hmm.
you need the cooling, and you need those cutouts to allow the air to flow through the fuselage and exit to the back. So with the IC, you don't need any of that. You close it so you don't get oil all over the back section
Right.
of the fuselage or something like that. So yes, it's definitely possible, right? Um, but would I do it? I'm not sure if I would do that because uh, to me right now electric is working so well.
Yeah.
It's trouble free, it's idiot free, and it's clean. It's
Yeah. It was more of a curiosity than anything, but
You
yeah.
could, because yeah, initially when I made this plane, I was designing it for what you just said, to be able to have a IC or a electric version if you choose to do so. And I even designed a crutch for it, and I had like the car path to make crutch molds and all that stuff. And later on, I realized that I've made some mistakes in the design because it was not very user friendly to make the parts. I put a lot of corners that were like very sharp, like that at 90 degrees.
Yeah.
And when you try to mold something like that, it's just a nightmare. Plus, it's weak on top of it. So, and when I decided to go electric, then I also decided to build for electric. And when you build for electric, you have different set of things to consider, right? Um, One of them was in internal combustion, you have a narrow margin between the low and the high. When you go to four cycle to two, four two, right? And let me put this on the charge so it just does the battery doesn't go bad. Okay, so in
Yeah,
IC you
Steve,
have
I'm letting Steve Hines in.
uh, yeah.
There you go.
Trey, I have a suggestion for you, Trey. I was watching your model. Was it Monday night? You were showing us how the front end comes off, and that's the motor and the batteries all in that one unit. That is just
yeah,
held on. I call them two Zeus fasteners.
kind of
Is
like
that correct?
not Zeus fasteners, but they are. It's a pin.
Camlock.
Yeah, it's like the IKEA furniture kind of thing more.
Right. Well, you should run a cable from your bell crank to your motor just in case something happens, because that's a live unit that could separate, from the
You will
plane.
never do that because it has a O-ring inside of them that stops them from rotating. They never rotated. I never had any issues with the system at all.
But I could even say, even if God, even forbid, say if you're doing a maneuver and you pancake it and that whole thing flexes and it pops out, you got a live rocket there that's going to take off.
Well,
You know,
Mark
combat and I see engines,
do like that.
you
Mark,
know, fly out, but
yeah.
you got your whole, if the battery was mounted separate, if your battery was mounted separate, the plug would pull out. But in your case, you have a live unit there, and so I would just say for safety, I would run a cable from the bell crank
Hmm.
to the motor, just in case something weird happened,
Yeah.
But just from what I was seeing, but it's spectacular, construction and everything else like that. But I just race cars and I know the Zeus fasteners and all that stuff. But when I saw you had the battery contained with the motor all in that section, and it came out as a component held in with that stuff, that was a concern I had.
Yeah. Well, let me tell you a little story. Mark McKinney had a little incident, and he smashed it a little bit.
Okay.
It stayed together.
All right. Well.
Yeah, it stayed together. I've flown this plane right now more than 50 flights, I'd say easily.
Right.
Never had an issue. The locking mechanism have an O-ring built into them, which prevents them to to loosen up by themselves. Worst case scenario, even if they loosen up themselves, they will
Right.
loosen up to the point they have like a little bit of slop between the fuselage and that nose. It can move a little bit, but that's
Right.
where the locking mechanism is going to stop. Even
Well,
if it,
Doran, I have no problem with it. I think it's stupid that we have to wear safety thongs, but you get the lawyers involved, and you'll be liable if that ever comes off.
yeah.
Right.
If
Yeah.
you ever get carpal tunnel syndrome in your hand like I did and start letting go of handles like I did, then you'll appreciate the safety thong.
Well, I mean, I saw planes. I saw planes leave the circle with the guy with the safety thong too. You know, the plane took off. He let go of the handle, and safety thong came right off his wrist. And when we do racing, we don't use safety thongs. You know, you don't have to use them in racing. You got 2, 3 guys in a circle at the same time.
Swap hands in case you get tangled up, like in combat.
It goes in the ground. You know, that's it. It's over. You know, but yeah, you know, you're not allowed to swat. You know, you're not
It's
supposed to let go.
it's the lawyers that do all this.
Yeah, well,
Well,
but
Just
you know,
send it
it's almost like that with any model though, because I pancaked the electric ringmaster in.
yeah,
It broke the fuse right at the wing,
okay.
and the whole damn thing took off.
Yeah,
But
well,
it only went about, I don't know, 6, 7 feet.
okay,
But it was flop. You know, it didn't fly. It was flopping and stuff and whipping around, and it went in.
right.
And then here this year on a IC, we had a handle break, and the damn airplane flew into the trees, and the airplane stopped, and the whole section broke at the wing again, and the IC motor kept going over into the neighbor's yard.
With the fuel line, fuel.
Yeah, it broke the fuel tank and everything went with the airplane.
Okay. Well, I mean, I seen flyways too. I seen
So
flyways.
you can be as
don't
safe
like
as you want to be, and then still shit happens, and depends on the way it happens. It happens, and
Right.
things happen. So
Right. I was kind of wondering about that with the other airplanes, if there shouldn't be, like with combat, a piece of line that goes in there and ties in from something in the front all the way back to the bell crank.
There is. There is.
Yeah, yes.
There is. That's what I was talking about. On a combat plane, you
Yeah, I
got
know combat, but I'm saying any plane. I'm saying, should any plane have a tethering system inside the nose of the airplane? Because every time you see an airplane crash, the nose breaks off, usually.
Well, usually with an IC engine, it breaks off. It leaves the tank behind. You know, or you know, flyaways are different. You know, the whole plane flies away when the lines get cut. That's why they have the swing weight shutoffs.
Yeah.
Just something that I just saw. You know, when I saw that contained unit, you know, I just had visions of. I seen engines fly off of IC engines, but they only go for maybe, you know, 25, 30 feet because, you know, they leave the fuel tank behind, you know. But that, or same thing with the electric job where the battery's mounted separately from the engine, you know, unless in your case where the whole nose broke off in front of the, you know,
Right.
wing, you know, but I saw that, you know, just watching his, you know, separation, you know, the way with the 2 cam locks, you know, I just saw that battery intact there as a unit. And that was the first thing that went off of my head was, oh boy, you know, what happens if the plane gets pancaked, inverted or something, and it, you know, and I think it only sits in there like 1/8 of an inch, you know, the recess, from what I was watching. You know, and it just, you know, flexes and pew, off she goes, you know.
Yeah, I don't know how far to go or whatever, you know. Usually,
Yeah, but it's just not that. I mean, it's a simple, easy fix just to run a cable from the bell crank to the motor. It's, you know, something just to hook on. That, you know, that wouldn't affect any else that he's doing there. I'm sure, you know, with all that stuff that he did, I would see it's, he probably could rig up something very nice, you know, very simple. You know, with
Well,
his ability.
basically all electrics are kind of, there may be an 1/8 inch balsa or whatever after the battery box hooked into the wing, but the front of the battery box, the motor bolts to, and then the battery is inside of a box that has a back on it.
Right.
And, you know, you could actually, if you didn't want, you didn't glue it in on the two sides, you could pick it up, and that's what I have for a test stand actually.
Okay.
That whole setup, turned it upside down and set it on a board, and then I can test run electric motors. But it's made, you know, actually bought from Brodak. And you assemble it, and then you put it inside the nose of the airplane. So it's kind of like it's being held on by 2 1/8 inch pieces of balsa or cam locks. You know, it's.
But the battery, the motor's plugged into the battery, correct?
The motor's plugged into the ESC and the ESC into the battery, but it's all in that box.
Okay.
Everything's all held into with a plywood box. So if you know, that was like with the Ringmaster, that box is turned on its side, and it goes into, I can go get it, but it goes into the profile, and when it broke, the battery, ESC, all that went with the
with the nose and the motor in the front.
Yeah, because you build the plywood box sturdy enough to take all the torque and stuff like that. When it breaks, it just said.
Yeah, it took off. Yeah.
So what I did was I took the timer and moved it, and I put it on the wing. So when it came apart, it would pull the timer out of it.
Right. Yeah.
And hopefully shut it off that way. But yeah, I got the timer on the wing now instead of on the nose, so it isn't all one unit. But that was kind of neat. Burnt my motor up because once it hit the ground, it stuck in, and the thing was sitting there flopping, and all of a sudden it let all the smoke out of it.
Right. Yeah.
Get smoke back in it?
No, I was gonna try, but this campaign not to smoke anymore. You know,
They never even taught us in electronic school how to put the smoke back in.
With the IC motors, when the smoke, it's bad when the smoke's not coming out.
Yeah, that's right.
Yep.
I saw your video, Rusty, on Stunthangar. You're playing the Super Satan going. Look good.
Yeah, man, it flies good, doesn't it?
Yeah, it flies good. Look good. I think he, on the video, he just had the needle slightly, on the lean side, and because the last, say, minute of the flight, the plane really was picking up. You know, before that, it seemed like it was a little flat, but then it seemed like it picked,
Yeah, because those bladders, I've noticed on my cafes as they begin to run out of gas, they go a little bit richer.
Right. Yeah. I could see that. It seemed like it was running better the last, like right before it shut off.
Yeah.
It seemed like it was really starting to go.
But then I think they overcompensated or something on the next flight when they did the speed test on it, and
They opened too much.
Didn't have it quite right either.
Yeah. And then, actually, I was watching. I don't know how Mike was flying with the speed test, but he had his arm way out there extended. When you got to fly like it's in on a pylon.
Yeah, that's right. That's a part of a mile an hour slower out there.
And he's a big guy, and he has it way out there. So he can pick up a few more mile an hour by bringing it in tight.
They still clocked it at 100.
I was happy with the way it ran.
Yeah. They clocked it at 108, I think.
Yeah.
That's what y'all had gotten up in New Jersey in the rain that day.
Yeah. Well, it's probably doing a couple better than that. Like I said, if he pulled his arm in.
Yeah.
But it was good.
Yeah. And watching them fly that thing, it helped me realize that that is definitely in my wheelhouse. I won't have a bit of problem flying that. You know, the only thing I've flown that's anywhere near that fast, which isn't really miles per hour wise, but the Gladiator on the shorter lines is a handful to keep up with. And
yeah. Reaction time, yeah.
Yeah, and this didn't look as hard as the Gladiator to keep up with.
Just when you go behind your head, when you do like an outside behind your head, that's where you got to be careful because it whips around fast.
Yeah.
You know. But yeah, no, it was looking good. I was with Tom Luciano Sunday. We had a combat meet in South Jersey, and we were talking about it a little bit. You know. So.
Oh, is that the same airplane on the floor there?
Yep.
Yeah. I was wondering what you were doing back there.
It looks like an IC engine sitting there.
Nah, actually, if I wanna pack this plane, it's gonna be packed something like this.
Wow. That's good, yeah.
Yeah, I was
This side.
disappointed you couldn't come down to Huntersville, Al. I hope maybe this spring or next fall you can get down.
Yeah, it's hard for me. You know, I have a business and I got to run it. And,
Oh yeah, I understand.
it's tough.
So the box will be about 40 inches by 15.
That's amazing.
And that's about 5 inches tall, 5.5 tall. That's how big the box will be for this guy.
Now, did you leave? You got your motor left in there?
Yeah.
What we did, like where the now where that cutout is, like where you don't have the front end of it there, we put a box. Yep. But I tell you, if you make a box and ship it in an airplane, don't leave the motor in it.
Mm-hmm.
Because when they throw it, the weight of it crashes and breaks stuff.
Yeah.
When we got
the
France, the whole
box would have Velcros that strap all the way around and locks it in place.
Yeah, that's how Samantha's was.
Mm-hmm.
And the whole belly of the nose was broken.
Mm-hmm.
It slammed it.
See, if you look from the back, you can see how I have all kinds of.
Oh yeah.
Flashlight. Give me a second. I'll go get a flashlight.
I don't have enough money or time to do all that.
This is a fascinating airframe.
Yeah.
What to build the part?
He said he builds it in a week.
Yeah. How long did it take to make the molds, and how much did the molds cost?
Oh well, yeah, right.
It's a different story.
So I will stick with balsa construction.
Yeah, I'm not quite ready to retool at this point in my game.
I already tried the electrics. Not for me.
Yeah.
I would like to have one electric plane on hand just for convenience sake. But yeah, I like IC. That's why I'm in it. You know, that's why I got into it.
Right.
So can you see that?
Oh yeah.
Oh yeah.
See, I have the 4 rails. It's just an L shape. You can see how much air goes around them.
Yeah.
Yeah.
Is this all open for the air to flow through?
Yeah.
That's
Got 100% cooling in that.
yeah. Was the cooling. So as soon as it gets inside, it hits the ESC. The battery is right behind it. As you can see, the motor mount.
Wow, that light's actually overexposing a little bit.
Oh, sorry.
It looks better with
Yeah, I like that motor mount. Is that piece of aluminum formed right in that when you build it?
Yeah, it's a machine piece.
Oh, okay. And you set it in the mold and then mold.
Yes.
Oh, okay.
When I close the mold, this goes inside
Oh, okay.
at the same time. So when I close the mold, this piece goes inside. That former over there goes inside. And this former over here goes inside. And the rest is done afterwards. And that's my switch.
Okay.
So that's the master switch over there. This is the on-off switch for the...
Do you have one of them arming plugs in it someplace?
That's it, right there.
Oh, right there. Oh.
Yeah, the light is making it worse.
Yeah, Brian, we can see it better without the light than we can with the light. So at least,
Let's see the arming plug again. Who makes that? Do you make that yourself?
Yeah. Yeah. There are 2 layers of brass that are they have a spacer in between them made out of G10 material.
Okay.
And they're all sandwiched with these 2 screws here. So the screw in the center, this screw over here, when you loosen it up, it
takes the light off.
Contact.
Take the light off.
Yeah, take the light off. Now,
we can see really good there.
Yeah.
So what? It's a pin then that just connects 2 halves of the.
Yeah.
Okay.
You know why they use this?
Why is that?
They use it in battle bots. This is the type of switch they use to arm their battle bots. The fighting robots.
Yeah.
Yeah.
I love that. I record that whenever it comes on.
Now the other question I have, and I did it like this too with Samantha's, with the switch and the arming switch. If you're going to use an arming switch, why not the little flip switch? Why not just tie them ends together and not even bring it out through the fuselage? Why have it off on?
When you arm put your battery inside, if somebody handles it from that point on, yes, it's doable.
You know, because what I found was I got the switch on Samantha's airplane. I always left it on. I never switched it. One time, once I figured out, if you just leave it on, put the battery in, hook it all up, put in the arming switch, it goes deep, 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 deep. You don't have to go from off to on.
6 of one, half a dozen of the other.
Yeah, I was just thinking of, for you could ease of doing it. You don't bump a switch or whatever.
This is one thing I want to deal with right now because I'm not sure if you see the insides here. This is my bell crank system. You could probably see it from the front better.
Oh yeah, we can see.
Yeah, and I see some of the pictures of that on Stunthangar.
Yeah,
that is really cool.
So what I find right now that I just want to have more flaps, and I'm not sure if you can see it from over there. If I want more flaps, is this push rod on the top here? That's my flaps.
Okay, so you just loosen up the 440 bolt
and slide it out a little bit.
Why would you want more flaps on that light of an airplane?
I want a little bit more corner.
Then take some flap out. You want more corner, you take the flap out, it'll turn like that.
More
flaps create more lift.
Watching it in slow motion in a video, and in slow motions, it flies the corner beautifully, right? It's no stalling, no nothing. But
right.
If I had more flaps, I get a little bit more lift.
Okay, give it a try. Get back to me. Tell me what you think. You're gonna be taking the flap out of it, because I'm thinking about cutting a 1/4 inch off of this flap.
That was with Samantha's airplane too. To get more corner, we went with full elevator.
Right.
I mean,
Like
when I'm
airplane-
on adjustment, yeah, I had the adjustment in the rear set up for as much elevator as we could get, and we got a lot more elevator out of than flap. Because what we were noticing is, if we use more flap on our turns, it stalled the airplane down.
Yeah.
It gave a funny look to when it came through that corner and went up. To where if we give more tail, it would snap. It'd fly through that corner. And she had enough elevator to do that. And that's why when I was talking to Bob Hunt about putting like the geese ski bear or whatever's got the flaps out on the end of the stab, that it even gives it more elevator to get your corner.
One more corner, you want to take flap out. You don't want to put more flap in it.
All right, then maybe I should try more elevator then.
Yeah, I tried more elevator. That's what, when we did Samantha's airplane, we sat there and played around with it, and it was more elevator.
And that doesn't work, Doran, is if your airplane's 70 ounces. Then you're going to have 1-to-1. But on a light airplane like that in the 50-ounce range, you're going to need, more elevator than flap.
Plus, you said that you fly yours a little more CG aft.
Yeah, my CG is to about here right now.
Yeah, so that's going to be the other thing with, you're going to need more elevator.
Okay. All right. I'll try.
If you got a nose heavy airplane, a lot of flap helps move that damn heavy ass nose up through the corner.
I did watch your flight today.
Yeah, I watched it too. The second one was a lot better. The second one you had posted in there, you were getting, it was a lot nicer. It does really super nice.
That was me flying. That was me flying in the first one. It's actually my friend Mark McKinney flying it. That's his fourth or fifth flight on the plane.
Yeah.
Oh, okay.
Yeah, all I watched was the second one because I was just
3 or 4 were just to set up a handle for him to his liking. So he was just getting a feel for it at that point.
Yeah. But I mean, for your inside and outside loops, it was very smooth. It looked like it locked in, and you didn't have to change anything through the maneuver. Sometimes you got to correct. It looked like once you had it locked in, you
not to have to guide it.
Right. It was really locked in on the move.
Yeah.
It was kind of hard to see from, and I don't know, all cameras when I watch a flight, it does something on the squares. It doesn't, I don't know, cameras don't pick up squares good or something.
Yes, that's true.
When you're watching them, it's like filming Samantha. I'll watch it and I can see it. Then we go back on the camera and it's like, that ain't how it looked to my eyes.
That's true. To the eyes, they look a lot tighter than that.
Right.
If you do a slow motion in camera, where you look on those tracks that you see on the guys that did the video at the World Championship, and the corners are a lot bigger than whatever your eye perceives as being the truth.
Yeah, the other thing is it gives like a false flat. It looks like that flat goes flat and it moves and it goes back up. I don't know. It's a weird little jive in the flats on them too, on the sides. To me, when I watch it from a camera, it doesn't look quite right.
Yeah. Yeah. What I found out was, like, from the video is that obviously you find out places where you need more work, but my biggest problem right now is that I have to change my flying style. I can no longer fly this plane the same way that I flew the planes I flew before. Because before I had to really fly the corners, be smooth and all that stuff. While this plane it's asking an ass kicking, He was like, give me some. And then he goes like, is that all you got there? So I can really wail on it on the corners and I have to just relearn it. So that's why I botched that outside square, yes, but but I still have to just work on my reflexes, because this is, if you notice in a flight, the corners are just explosive.
Yeah, you just got to get used to.
Yeah.
Get used to the airplane. I mean, Samantha had the same thing with her. The ones we took to the world, she did not have enough time on it, and by the end, she was really getting used to it. But she said it was, you know, there was not another plane that flew like that. It was so different flying that airplane over what she was normally, you know, flew. That she was just having a hard time. But you know, I think that a lot of these airplanes fly so crummy that you try to adjust things and stuff like this, and she had to get used to when she came out of a maneuver. That's where it ended up. She had it nose down a little bit, nose up a little bit. It stayed there. It didn't bump or waver or you know. So yeah, it's a different airplanes fly different ways, you know, and you got to get used to them.
Well, actually, even the same airplanes fly different ways depending on how you are setting them up.
You know, that's, I think too, is that you know, probably Sparky can contest to building this basically the same airplane and have a light one, and how that affects how the airplane flies and what you can do with it.
Yeah.
You know, it's like when he was there at Brodak and the judges were set up wrong, how he could still turn and fly the airplane fucking 90 and 180 degrees against the wind, because it had so much power. It was so light, it just didn't affect the airplane like a normal heavier plane. Where other people were having problems with the wind, he was just flying through it like it really wasn't there.
Yeah, it's like some people can definitely trim a plane and get it in perfect flying condition and stuff like that. Other people still have to learn it. Yeah, and go all kinds of different directions for them.
I'm still working on my leftover Halloween candy. Marty's.
Did you guys see that Jimmy Kimmel thing this morning on TV where he had parents empty out their kids' candy and tell them that it was the moms on there saying that they got hungry at night after they went to bed and they ate all their candy, and kids are looking and they have no candy? It was so funny.
That plane you painted, that one's painted on the, after you molded it?
Yes.
Now I have a question. You said you were going to paint it in the mold.
Yes.
Before you lay everything up?
Yes.
So you're painting the, you know, you're painting that, you know, your mold first? What are you putting the paint on? The mold itself?
Yeah.
Probably a gel. Well, you probably hit it with a gel coat first.
No, you hit it with a clear coat first.
Or clear coat, gel coat, yeah.
Well, clear coat what? Wait,
Yeah.
you're putting what on the two-part auto clear?
Yes.
Okay, but what do you, I guess your mold is some kind of Durlon or something like that?
Yeah, you can paint in the mold, yes.
Right, so you paint the mold so the paint doesn't stick to the mold.
Yeah, I mean, the mold has PVA in it first, right?
Polyvinyl alcohol goes on first, then it's wax, then PVA, then he paints it with clear or whatever, then he lays in his color stripe, just like doing a boat. Then all the resins and the carbon goes in there, and when it's released, it's all in the resin.
Right. Okay, I got you. All right.
Is it really any lighter doing it that way? Would it be any lighter to paint it in the molds than outside the molds?
Not lighter, but easier, and perhaps lighter too. Yes. Because and I'm telling you why. Because if you paint in a mold, your paint job, when you pull the part out of the mold, is nice and flat. You don't have to clear coat it or do anything to it.
Okay.
To cover, like if you have a paint job like this where you change colors and you run your fingers over it and you feel all the bumps and stuff like that, then you have to clear coat it and sand it off until you don't feel anything. Well, that's all gone if you do it in a mold.
You're doing it from doing it from the inside. You're putting the clear on first, and then you're putting the paint on the inside of the clear, sort of like a model plastic car.
You know,
so the clear goes first, and then I would put like the color, like the yellow here, then the white behind it.
Right.
If I do some maybe the name, stuff like that. And then you lay the material inside. And when it comes out of the mold, it's already painted with a nice color scheme, and everything is nice and flat. You run your fingers over it, nothing happens over there, and it's durable.
Yeah, we tried, you know, a long time ago. You know, we used just lacquer paint, so I don't know how the automotive paint is different than lacquer or whatever. But we did that, and once we popped it out of the molds, our color wasn't constant. Someplace we were heavier and lighter, and you could really see through the paint. And some we got it too thin. We had such color difference.
Yeah, problem with painting in a mold, and you have to know what's going to be underneath the color. If you come with black like this underneath the color, you put what's called a blocker coat. So it's either white or silver. So after you paint all this stuff, you want to come with a coat of silver behind it to block the darkness come through.
Oh, okay.
From the other side. Or white is just fine. And when you paint in a mold, because my mold is color red, you paint until the red disappears completely. And that's how you know you got it right.
Now, did you paint your molds red, or is that the material that's red like that?
Material is red like that.
Oh, okay.
Yeah. So you see my hinges, I have no hinges in here. It's a Kevlar strip inside there.
Okay.
If you're looking here, I have no plastic hinges. They don't exist.
And so there's no air gap, no taping your hinge lines.
Yeah, correct. Yeah.
That is cool.
So,
and then, what do you bond the two halves with, and your internal structure? Are you using an epoxy?
Yes, all the bonding is done with the same epoxy I use to laminate stuff.
You use an easy lam?
No, I use MGS epoxy. MGS, it's an aircraft rated epoxy. It's made for real planes.
Okay.
So the quality of it is very good. It's a very fluid epoxy. When you mix it up, it's almost water thin. A little bit thicker than water, but it's definitely very thin, and it has the ability to penetrate and it goes through everything basically.
So are you putting a breather cloth in it when you bag it and sucking the resin off, or are you
yeah, I don't need that. What we do is after we put a layer of carbon inside, we put paper towels on top of it, and we vacuum bag that stuff for like 30 seconds, and that sucks almost all the resin out of the carbon fiber. And the inner layer, which is the foam with a fiberglass on it, when I wet the fiberglass, I wet it with a very dry roller. And when I do that, it's you leave very little resin in the material itself. So we really don't need that. You need that if you are very sloppy and you put the resin and take it out. But then into the danger of having your having the whole layout pop out of the mold before you close it.
So is that carbon 0.2 or 0.5?
0.5 what?
grams or whatever per yard?
No, this is 30 grams, close to about 30 grams per square yard.
So 1 ounce, basically 1 ounce a yard.
Yes.
1 ounce cloth.
Yes.
Okay.
That's not where the weight is. The weight is in the resin.
Yeah.
Yes, it's if you look at the carbon to resin ratio, it's about 1 to half. So if the carbon is 30 grams, you have 15 grams of resin inside of it at a minimum.
Oh, okay.
But I had a bad wing.
Right.
And I cut this section over here, which was about I think it was 5 inches by 20 inches long, and that whole section, the part of the skin was weighing about 11 grams, 12 grams or so. So
Now,
the wing panel like this comes out of the mold at 130 grams.
down the middle there, what are you putting down the middle of the wing to keep it from, like, I call it oil canning or whatever?
That is just a single. It's a vertical wall.
Oh, okay. Oh, I seen two there. I didn't know if you had two of them going.
This is not the second one.
That's just a brace.
Spacer here.
Oh, okay.
Any further, anything deeper in? Deeper inside or no?
No, nothing. Nothing. Just the wing skins and the vertical wall here.
Okay.
So that wing weighs almost 9.5 ounces total.
Yes.
130 grams per side.
Yes.
Yeah.
Yeah, the wing pair is 9.5 ounces.
Yeah.
There.
And you were talking about, being that you have the wing in your hand, you mentioned that you have the airfoil design, so you have the most of the lift in the center of the wing, towards the center. The airfoil, you said you had something designed so the lift.
Like he had Senko
What
wing.
wing tips are thin. Look at that.
How thin they go down?
So okay. So it's tapered. Yes, you have a heavy taper in it.
Yes.
Yes, okay.
I'm taking the lift out of the wing tip.
Correct. Yeah, that's what I was, because I saw you. I heard what you mentioned it. I was trying to see exactly what you were, reading about that.
Now, is that a straight trailing edge or a tape? Is that a taper on the trailing edge too?
Not so much.
Okay, so that's straight on the back side of the.
But if you look at the root of the wing, you have a little bit of this right here on the flaps, right?
Yeah.
The tip, it has a smooth flowing top and the bottom.
Yeah.
Oh, okay. Yeah.
Flaps is deflecting because this is a little bit inefficient. It's going to produce less lift, while it's more efficient at the root of the wing. So I have when I deflect the flaps, the lift is more concentrated towards the center as well.
Oh, okay. All right. Yeah, I kind of wondered how you did that.
You can only do that with a molded wing. You couldn't do that with a built-up wing like this.
Right. Yeah.
Yeah, exactly.
Because
Look at the Senko shark wing. It's thick in the center and it's elliptical. It has a curve on the top and bottom. It's kind of strange. But you can only do that in a molded wing. You could never build that with a foam wing or with a built-up wing.
Well, why not?
How are you going to cut foam around the corner like that? Or how are you going to lay out a wing that arcs in this direction? I don't.
First of all, Adam Mason and Warnowski, they both build up a nice elliptical wing, so it's possible to do it with wood.
They have elliptical wings on the trailing edge. It's I can see that because they did that with like a Thunderbird. Elliptical wing and a plan form on top. I'm talking about from the root to the tip. If you look at the leading edge of the wing on the Yatsenko, it's
Well, for that, obviously you cannot use a block of ribs and cut them out. You know, you have to do it basically independently one at a time. Or when you do your CAD program, if you do it in CAD, you know the exact position of each rib, and you do cross sections over there, and then you have the exact shape of the.
You might be able to do it in CAD. It'd be a bitch to build.
Yeah, it would be a pain in the ass to build. I like that, how that wing builds up a whole lot easier.
Yeah. Well, but yeah, and that's we're coming around to my decision to make a straight taper wing. But what I've done, you can achieve the same thing with a straight taper, but make the wing tip a lot thinner.
Right.
Percentage wise.
Yeah. What got my attention when you said it flies, it tracks better in the wind. You know, that's.
What it does in the wind, which I noticed in Huntersville, where it was a little bit turbulent, right? When I went above the trees, a little bit cleaner air, where it still was, the wind was blowing a little bit, was not dead calm. What I noticed that as you come with when you climb here with the wind behind it, the plane is not being accelerated a whole lot. I mean, just almost keeps constant. And as you come like this into the wind, because the airfoil is so much thinner, it just cuts through it.
Right.
Slowing down. So because it doesn't slow down, it doesn't accelerate much. The control over here, especially when you get on the top side of hourglass, the high up maneuvers, so they're almost effortless. It just punches through it.
That's good. Yeah.
So that's what I've noticed, and even in a 4-lift Clover, when you do the first loop over there, not an issue. But at Huntersville, when I was flying over there, after I came home, I started to play with the lead outs, and I found out that my lead outs in a very shitty position. So I was whatever I was flying there, and including in that video over there, it's
you move them back.
What?
Did you move them back?
Yes. Yeah. I noticed it was flying inside towards me a little bit. I was flying. So, yeah. So what you see in a video over there that I had, the last video I posted, actually it's with a shitty trim setup. And still it's even like that, it's formidable still in the air. I mean, it turns, I don't know, when I was watching it and I was watching the rate of turn and then the flats that, it just turns, locks, and goes.
Excuse me. Hey, Jamie, is your microphone muted on purpose? Okay. Just making sure. Sorry to interrupt. I just wanted to make sure it.
I have to say that goes together a whole lot faster than what Samantha's airplane did. It was like a 2-hour deal getting that airplane together, and because the stab goes on and.
Oh wow, really? I had no idea it took that long to put it together.
Yeah, Chris can put his together fairly fast, but you had to put the flaps on, and so you had to run the wire down through there. And I mean, I finally ended up getting an X-Acto knife, so that when I fed it in, I could take the X-Acto knife and lift and lower to hit the hinges as I put the wire in. That took the longest, and then getting the tail back straight.
It is in my line release.
Yeah.
Right.
Yeah, it snaps down over top of that.
Yes.
Yeah, that's.
When I'm done with it, I just open it like this, and it falls out.
All right.
And then I just close it back in.
I think you just yanked your camera cable loose. There we go.
Yeah, that was like with Samantha's airplane. We had to stick the cables on, put her inboard wing on first, run the cables out, turn the bell crank all the way out so I could get to it, and then the lead out, the bearing, and all that stuff that went in. But yeah, you had to realign the tail and everything.
None of that.
Yeah, that doesn't have to do that. But yeah, with Samantha's, we sat there and play around getting the tail all aligned and everything. And
this is the way with the lead outs.
Yeah.
Just do this. Take the bell crank, put it on, close it. This is one side. Wires on. Close it. Get your wing. Put it in. Fit the flaps in there. Wing is in.
That's incredible.
Yeah.
And then you go on the bottom side and lock at the bottom too. And it's all half a turn thing. And what you don't want to do, you don't want to over tighten it. Just a gentle snug it's all.
And you made those, I call them Zeus fasteners, but that's.
This is not Zeus. This is like an IKEA furniture kind of lock.
The cam lock.
Cam lock or whatever.
Cam lock, that's what I call them. Yeah.
And obviously, the last of it. You just put the spinner back on. This is something else. This is like one of the spinners that I got, so I cut out this.
Yeah, the back plate to let the air
Is that one of those Great Plains aluminum backs that you made that out of?
I don't know. What's his name? It's a guy that sells them. Dave.
Dave Brown.
Yeah, Dave Brown. It's Dave Brown.
Yeah.
Spinner, yes.
Yeah, Great Plains relabels his stuff.
Yeah,
Well, I didn't realize Dave Brown made stuff for Great Plains.
Well, OmniModels.com or the eBay OmniModels store sells Dave Brown spinners with the Great Plains label on them.
I see.
I get the aluminum ones with the big nut in the front of them for about $15.
I see. So obviously, this is more like a show and tell.
Yeah.
But in all honesty, I could probably just put this plane together in a matter of just 5 minutes, maybe.
So you don't even worry about getting that one prop blade up at 1 o'clock, so it goes on to compression.
Yeah, of course. I have to make sure that's correct.
You got it marked, huh?
Yes, I do. Yeah, it's in perfect position right now.
Is that where all the electrons pile up?
Yeah, you got to line that. You got to line that prop up. But yeah, that's a really nice take apart.
Yeah.
Really nice.
Yeah, I tell you what, that's an impressive piece of work there.
Yeah.
And y'all remember from the other night, the landing gear can be reversed from side to side to give you either a grass position or an asphalt position. Or
Well,
the far backwards.
if you got a smaller car, like when we were in Europe, it would have been a whole lot easier to drop off one wing, take a wing off the tail, and you can put it in your car and then set that down. Be very easy to transport it in a vehicle.
Yeah. So we're all up until Dorian came along, were all take aparts a 2-hour job to assemble. Geez, I have no idea.
Probably not. Some of them guys can put them together in 15, 20 minutes, but they got plug-on tails. To where Samantha's was, when it went in the box to get everything to fit, the flaps had to come off. So that was the hardest thing is for me was getting that piano wire all the way down through all the hinges.
Uh-huh.
You know, and
Yeah, I've never used a wire hinge, long hinge like that, but I've seen it. I knew people did it like that.
plus with old eyes, it's really hard to see that little teeny ass piano wire.
Yeah.
You know, here I try to move the wing out back in, get the X-Acto knife there, push. You know.
Samantha could have done it in half the time you did.
She tried to, and she couldn't get it, and so finally I ended up having her hold the wing for me so I could move in and out and see it, and then I fed the wire, and that worked the best. You know, for the second time we put it together. But
Terry Forbes says, okay, he's getting one of these planes, except he wants a glow one.
yeah, we can paint it with glow in the dark paint.
Make it pink or whatever.
Yeah.
Yeah. Well, if I'm gonna paint it for anybody, you know, if they want a special paint or something like that, they're gonna have to do it in CAD themselves, or else I'm just gonna do my paint job, which is pretty nice, I'd say, and call it and put their AMA number on the plane.
Yeah.
You should just paint them white and let them do whatever they want to do.
Why would you do that? First of all, paint adds weight, and not a whole lot in my case. But
they want to paint them.
Yeah, but the carbon looks cool.
You need to come up with white carbon fiber.
How many appearance points did you get at the Nats this year?
What?
How many appearance points did you get for that at the Nats this year?
I got 15 for it, but
that's why. That's why you're going to paint them.
Yeah, I got 15, but you know, it's a crude paint job that I just slapped it on one day before I went to the Nats. So me getting 15 points for it, I was just quite happy.
I'd say 15 points for a one-day paint job's pretty good.
I'll take it, yeah. So my biggest problem was that the aft section of the fuselage had some carbon fiber in there that didn't want to fill in the grain very well. And it was very coarse. So I had to put a lot of, you know, filler putty and all that crap to get it to fill in, and then silver it, sand it off, silver it, sand it off a couple of times to get it nice and neat to put some kind of color on top of it. So that was my problem with it. And I was just hacking it up literally just the day before or 2 days before the Nats, and before I left to the Nats actually. That's my story on this plane. I'm sure if I would do the paint job inside the mold and stuff like that, just stripes, maybe a couple of colors, probably just what you see here, the white and yellow kind of thing, maybe different colors. If I do that in a mold, it's going to look very beautiful, and the carbon comes out and is very pleasing to the eye when you look at it. Mm-hmm. Besides, it has this pattern on the carbon that's kind of randomish, but still it's beautiful because it pops.
Yeah.
I think, you know. So this is because this is the kind of finishing you would get out of the mold. If you see it.
Oh, okay.
And this is how the carbon looks. Can you see that?
Yeah.
Yeah.
So you have a pretty pattern over there. So I just leave it the carbon as is, just put some stripes on it, like something simple, and this should work out.
So are you cutting like the vinyl paint mask, and then you put the paint mask inside of the mold, paint it, then pull the mask back out?
Yep, that's exactly what I would do.
Oh,
Yeah.
okay.
And I would go even one step further. I'll put a paint mask that has both colors into it. So when you put it down, you just take out of the mask whatever is the first paint job, right?
Oh, okay.
And just let me grab that for.
Anybody that's going to do any rubbing out of an airplane needs to get one of these, the Dremel Versa.
What is it?
The Dremel Versa.
Oh, shit, I didn't even know Dremel made a little hand polisher.
Yeah.
When did they come out with that, Sparky? You had it for a while, or?
I had it a few months.
I've never seen one, you know. Basically, Home Depot has the biggest thing of Dremels now around. I've never seen that at Home Depot.
I bought it at Lowe's.
What, Lowe's? Oh, okay.
How'd they go again?
There he is.
So yeah, I would paint the color first. Like for example, here what I did, I painted the red color first.
Okay.
And then we mask. I took the masking off of this color here, of the white, and I paint white behind the red as a blocker, as well as the stripe here.
Oh, okay.
And then when you lay up everything, I mean, if you run your hand over here, you can't feel anything.
Right. Yeah.
Oh, so if you wanted to go with 3 colors or whatever, then you actually, it doesn't really matter if, as long as you got the white blocker on at the end, everything will cover.
Yeah,
you have a little,
use a light color.
If you had a little overspray on one of the other colors, it ain't gonna matter.
Who cares? I mean, you can take a piece of acetone and a rag and then just wipe it off.
Oh, okay.
It's 2-part paint clear on the other side, right?
Yeah.
If you make a mistake, but you know, actually, yeah, and that's one of the reasons for which I made the paint job like the way I did it on that plane. You want, if you have the blocker coat as a, you know, as a trim for the sides or something like that, like in that case.
Yeah.
I had yellow on the center with a white borders and white everything else. That's easy to make because you have a stencil and you have the windows for the yellow first. You shoot it up and then you peel off that mask and you reveal, now you have the blocks in the center and whatever is left over, it's white color. So you're blocking the yellow and you also put the white border on the outside.
Oh, okay. That makes sense.
And when you lay the material inside there and you pull it out of the mold, it's nice and flat and smooth, and it's like, this is what you get. I mean, this is quality stuff, right?
Yeah.
And the only thing I would do after that, I just probably take and put some panel lines or something like that. And if you run your fingers over and you feel a little bit over those panel lines only, I think it would be something cool, you know.
So
you should feel panel lines.
So you're putting your tapes down, your tape pulls down. Say you have 3 different colors. So you got your 3 tape or your stencils. So you pull the one, say that's your red, and then you pull the second one, that's your white. Then you spray over the back of the red and the white. Then if you pulled your third one, say the next one is yellow, you pull that, then you would be shooting yellow over everything also.
I would shoot the red, I would shoot the yellow, and then pull the rest of it and shoot the white.
Well, yeah, yes, right. But
and the white is going to be the blocker, and it's going to also be white whatever you do.
Right. Yeah, I got you. That you're layering it on the inside, not the outside.
Yes.
Yeah.
You just got to find out a way to dye carbon fiber the color you want, and then you don't even have to paint.
Carbon being carbon's going to be hard to make anything but black.
So, you know, when
we figured out all the other stuff, you should be able to figure out how to make, like, say, purple carbon fiber. If you want,
you're gonna have to get down to the molecule to do that, I think.
when we're doing the stripes on cars, we put the base color down, then you put your stripes, and then you know, then if it's another color, then you have to do the other one, the stripe. Then you clear coat everything, and then you have to wet sand it all down, you know, sand it all down, and then clear it again, you know, if you don't want to feel the ridges. You know,
Yep.
that's, you know,
You
very
hear me about you guys want to make colored airplane, Higgins ink in the resin or Rit dye in the resin.
mm-hmm.
Dye the resin.
Dye the resin in the carbon fiber.
Yeah, you could probably put a tinge of then a color in, like say if you wanted purple, you could make a purplish black or.
I don't think
make
that
white.
it's gonna be strong enough to cover the black of the carbon. It's still gonna be black. But you know, like on the same token, you know, like if you want a white plane or a purple plane or you know whatever, you know, if you want to start with a background color, that's perhaps the easiest thing you can do in a mold, because you just take a 2-part paint and to the proper color that you wish to have, and in this case I would spray the clear very, very light, you know, almost just dust it off only, and then come with the next coat immediately after that with whatever background color you want to have, if you want to have white plane or whatever color. It's gonna be business as normal, you know, just lay up the parts, and next day you have a wing that's already with the base color on it.
Yeah, that would be a lot easier.
Yeah, but I just don't want to mess with that after that. When I pull the part of the mold, I would like it to be done, finished.
A whole lot easier than this rubbing and sanding.
Oh yeah.
Yeah, but you enjoy that though, Sparky. You wouldn't have nothing else to do with your time if
Right.
you weren't rubbing out of an airplane.
Then time.
That's like a quarter of Sparky's free time is rubbing airplanes all year long. So when he gets done rubbing this one, he'll build another one. Then we'll see him there rubbing on an airplane again for weeks.
Takes 100 hours to get it right.
Yeah, I wonder if you could do that like candy apple paint, like a translucent. It looks like cherry syrup. You put on the candy apple coating first, and then you put the gold base behind that, and then you would have to put then you have to put your gold blocker behind that.
Yeah.
Clear, candy, gold, white, and then lay the resin. Yeah, you could do it. It's just reverse.
That would look spectacular.
Yeah, you can do some fancy stuff. I mean, my aunt worked at this boat company in Florida, and they made some real expensive speedboats and stuff like that, and it was crazy.
Yeah.
What they did. And they actually put like metal flake over carbon fiber and stuff, and it looked really cool.
You can do anything with it, yes.
Yeah. Yeah, it was carbon fiber with when it hit the sunlight, then the carbon fiber would have all this metal flake that showed. It was hard to believe the stuff they could do, but
yeah, I mean the carbon itself, like when the sunlight hits it, because it has the weave in all directions.
Yeah.
And when it reflects off of it, it's almost like a candy black or something like that.
I'll show you what you should do. I'll pull up this video and bring it to you. I'll present it to you. It'll blow your mind.
Yeah. I painted. I had a Corvette. I painted it candy apple red, and it came out gorgeous. And I used the red with the gold base coat underneath it. And that car in the sunlight, that was like a showstopper. Everybody stopped by. It's on my Facebook page. It's on my background, and that car, it came out so nice. It would just glow.
I painted a go-kart when I was a kid, candy apple blue.
Right.
And I worked on that thing for weeks because just doing tubing, if you got a little bit of a sag, it changed the color.
Right, yeah. Well,
and I was sanding and I was fixing and stuff like that. But I tell you what, when I took it out to the racetrack at the state championships and they seen that thing, they were like, "Oh my god!"
No, it's very hard to get it to lay out nice where it's not blotchy. You know,
Yeah.
Watch 2-minute video.
you know, on a big panel on a hood or the side of the car. You know, laid out nice. You know, if you're just doing like a tank or a fender or something like that, it's easy. But when you're doing a big car or a van, it's a nightmare. You know, make that color lay out nice.
So this guy's doing it with a brush.
Man,
Brush on chrome paint.
now it's wild. In a few minutes, we'll see it turning into an unbelievable grow.
Right. Okay.
They don't sell this in the States though. Starting already. Okay, let's brush the rest, Mr. J-Lo. Okay. Like $200 a
Continue this gas. Oh, that's that. Yeah.
Even though those rip marks are there, we'll smooth them out.
Oh, I remember this video.
Yeah. By the way, I think that brushing is much faster than spray.
Is that chrome paint?
Yeah.
It is.
Oh my goodness, that is something.
I can't believe what
Yeah, just watch it when it hardens.
It's true. So we are. The rest is drying off. There was one that was both poured on and brushed on. Okay. And,
Good God.
Here,
That's it.
as exciting as it gets, you know, to watch paint dry. Look at that. Just touching it
Hang
up.
on a minute, Al. I'll click on yours when you put it back up.
Oh, okay. Well, I'll wait till he's done.
I want to put some of that chrome paint on my Cardinal.
If there's any marks, buff them out. Hexavalent chrome, no doubt.
There's the Corvette. What year is that?
There's a 75.
Well, easy chrome. And you don't
Is
need
that a 25th anniversary? Or no, wait a minute. That would be.
I still go down, go away. Aloha.
Is that a 20th anniversary vet?
No. That's something I customized. I took the hideaway headlights out, made it look like a Mako Shark front end, put the spoilers on it, street wing, side exhaust.
Now in that video, Sparky, did he go over it with that red color?
No. I'll tell you what, if you look on YouTube, there's guys spraying that stuff on a car. They turn a whole car chrome. One guy's spraying that stuff on, the next guy comes back with water, and they're spraying water all over it real fast.
Boy,
Turn
that
the whole
could be a
car
real
chrome.
hazard on a sunny day.
No shit. But they don't sell it here because it's dangerous, probably, huh?
Yeah, I looked for it because they give a link to it. I looked for it, and it's only in England. They only sell it in England because our EPA, I guess.
What did you say it was Hector something or other chrome?
It's hexavalent chrome. It's the only thing it can be, and that's real toxic.
Yeah, I was gonna say that's
I think it's a.
Aaron Brockovich. That was that whole thing.
You know what's cool? You ever see the guy do the water stencils?
Yeah,
Where
where they float them.
Yeah, they float them. They float everything on. The guy, I saw some guy did a bunch of skull heads and stuff, and skull heads on fire, like fire and flames, and that's amazing. And some guys got that, big tanks where they put in big panels. It's pretty cool stuff.
Hydro dipping.
Yeah, they were doing that on American Chopper. They took a tank instead of hand painting or whatever. He floated that thing, and that guy just walked over there, and he's like,
Yeah.
Well, I would have had a little bit 3 degrees out, and then the lines would have been straight on the. How he dipped it in there, and everything came out exactly right. I'm like, wow.
And then they got into this new stuff where they're spraying the cars, and it's, I don't know, it's almost like a rubber. You refinish the car, and then if you don't like the paint job, you can pull it all off.
Yeah.
I saw that on YouTube also.
Yeah.
Hey, Doran, what do you think of my prop there?
It's a prop.
It's ATC.
How much?
ATC 3-blade.
Oh, you dyed it with RIT dye?
No, it's carbon.
Oh,
Oh, is that one of Bob McDonald's?
Yeah, they work great.
Yeah, I got some that Jeff Truxler made up
I like the shape.
out of them, and then also the BY&O.
I definitely like the shape on this prop. I mean, looks well made. I mean, how is the pitch on it? Did you check the pitch on it?
It's 4.5.
No, but did you check it on different stations and it's
Yeah.
pretty good?
It's
Okay.
real consistent. What Bob did was he took an ATC propeller and he cut one blade off. And then he laid out the mold in the 3-blade and laid this up in carbon.
Mm-hmm.
And I bought a couple of them. I'm going to buy a couple more so I can get different pitches. But yeah, it's real consistent.
What diameter is it?
That's 14.5.
14.5. Okay, cool. Yeah, yeah. It's nice. Looks like a nice prop. I mean, just what can I say? The shape is good. Shapes looks right. It just
Yeah,
looks
that's what
right.
Jeff Truxler has a jig that he cuts somehow. He cuts that one blade off, and well, actually, cuts 3 blades, and then he's got the right angles and stuff, and then that goes together, and he hooks it up, and then makes a mold. And I see his molds; they're pretty cool. But he made one for Billy Werwage. Chris had some of them or whatever, but Billy was still sanding on them. He wanted it more under camber or something. I don't know.
This has got a lot of under camber. A lot. Whatever happened to your molds, Doran?
Well, Wendy has one, and some other guy has another one. I don't have them anymore. But yeah, I was thinking about making some. Eventually, by the time when I'm gonna find out what I really like on this plane, I'll probably end up making some special propeller blades for it. And I'm thinking about molding single blades and make a special hub for them so I can put them inside, like make a 3-blade prop or 2-blade prop or whatever. But most likely I'm going to end up with a 2-blade prop because it's electric and they take less energy. And I need I think I need a little bit more drive on the plane right now, just a little bit more. But I don't seem to really lack the drive. I mean, it's just what can I say? I just have to get used to the plane and flight and some more and get to know it.
what, do you think it just needs a little bit more authority when you need the horsepower? Is that what you're saying?
Yeah, I mean, I feel like maybe I should have more pitch to the motor to allow it to brake on the high end a little bit more.
Mm.
But like I said, it's just right now this is the first propeller I put on it because of ground clearance issues.
And what pitch are you running now?
5.
5.
Yeah.
Well, the bigger the blade, the harder the bigger diameter the blade will slow your turns down.
Yeah, it all depends. If you go, it's a bit of a misconception over there. You are true. You are absolutely right. If it's a heavier prop and the same pitch, spinning at the same RPM. But if you go in a large diameter, you also want to increase the pitch to it, which will lower the RPM. And now, depending on the weight of the prop, you may break even or even better.
I've been playing.
A 2-bladed prop should be lighter anyway because you have less blade.
Yes.
Yeah.
Because
my Thunderbolt prop that I used to run on PA75 was a 15.5 or 15.45, and it weighed 2 1/4 ounces. This prop here is 1 1/4 ounces, and it's almost as big.
But what it is that if, you know, like this right here is a 12-inch prop, so that's 6 inches. So you got 36 inches of blade here. If you only wanted to go, if you say you went to a 13, you got 26 inches of blade. You only went an inch bigger. So you've cut down a shitload of weight. You cut the weight in almost a third.
Yeah.
How do you figure 36 inches on 3 blades?
Well,
if that was 12 inches, say I said that was like a 12-inch blade, 12, 24, 36. These aren't 12-inch blades. But I'm saying, you know, it doesn't matter what you do. So these would be 6-inch, so that's 18. So you have 18 inches of blade here. You use just 2 of them and measure it. You only got 12. Well, if you want 1 inch bigger on the diameter, now you got a 13-inch blade. So you've knocked off 5 inches of blade, and 5 inches of blade weighs something.
but what I'm just talking about, if you have a bicycle wheel and you hold it by the axles and you spin it and you try to move it, you feel a resistance. The bigger that wheel is, the harder that resistance is going to be.
And the fact,
It also depends on the RPM on your bicycle wheel.
right, how fast you spin the wheel.
Right.
You spin it really slow, or if you really spin it fast,
Right.
a little like a gyro. Remember the kid? They only had the thing was only that big, but it was spinning 18,000 RPMs or whatever. It's hard to move that.
Right.
If you spin it at a mile an hour, 1 RPM, you can do anything you want with it, and it's still spinning.
Okay.
Because you get the gyro effect.
The idea is that if you want to achieve this, say 100 ounces of thrust and 55 miles per hour, right? You can do it with a 3-blade 12-inch prop at 11,000 RPM, and you also can do it with a 2-blade prop at 15, 16 inches of diameter and at 7 inches of pitch at 5,000 RPMs.
Right. Okay, I got
So
you.
you go 5,000 RPMs with a little bit more diameter. If you do the math, the same exact math Igor put over there to justify his, to calculate the precision, you're going to find out that you're better off with a bigger prop at a lower RPM and more pitch. And you maintain the same amount of thrust and you maintain the same speed at the same time. So you didn't change anything.
Yeah.
So your acceleration out of the corners is the same because you have the same thrust as before. And the speed is the same. So you don't change anything. But there are 2 completely different case scenarios. Now, what we are talking here, we're also talking about thinking in electric terms, because electrics and IC motors are completely the opposite spectrum of each other. Electrics love low RPM and they have a lot high power at low RPM, while the IC, the more gas you put in them, the faster you spin them, the more power you generate.
Correct.
So,
Yeah.
if an IC you want a small diameter, small pitch at high RPM, on the electric you want to go completely opposite. You want to go big diameter, high pitch, low RPM, where they're very happy. So again, in IC you have a very small window between the 2 and 4 brake. We're talking a few hundred RPM. So you need the airfoil a little bit thicker to compensate and create some drag to the plane to hold it from going crazy, right? While on electric, you have through the accelerometer, you have this the band from high to low can be everything. It can go from full power to idle or stop.
Well, I'm out of here, guys. I'm gonna.
All right. Take it easy, Sparky.
Okay, Sparky.
Don't do too much buffing.
Take care.
Save your arms.
I'm experiencing all that now. I'm working with a Gardner LA 46 piston and liner where he slowed the timing down, lowered the timing. So I tried the normal APC 12 and was it 12 and a quarter by 3 3/4 prop, and my Vector didn't like it. So then I went back to put my LA 40 prop on, which was a 11.5 by 4, and the plane flew better, but the engine didn't like it. So then I just tried a master air screw 3-blade 11x6, and it was like a magic prop. The plane turned beautiful. The engine, it gave it the speed because now the engine's time blower. It's running at a more torque at a lower RPM, and the whole everything is coming together now. So I'm in the middle of trimming that.
Yeah.
But I couldn't believe how good that master air screw 3-blade 11x6 is.
Yeah.
Really good.
Yeah,
Yeah,
we found that on. Oh, go ahead. Well, we found that on these stalker motors that like to turn at 6,000 RPM. You need to put a high pitch 2-bladed prop on that thing, and it makes all the difference. I mean, they turn so much better and stuff like that, And
Yeah.
you wouldn't think it would, to put a bigger, higher pitched blade on that it was going to make that airplane fly better, but they fly better. They turn better at a lower RPM, bigger prop.
Well, with IC engines, first thing you want to find out about your IC engines, how much load do you need on it, right? Yeah. So you probably want to try a small prop, and if it breaks in a 2-cycle, it stays over there, or even accelerates, stays in 2-cycle, you don't have enough load on the motor. You need a bigger prop. So you keep increasing the diameter of the prop until it starts to 2-4 break, and that's the RPM that the engine is very happy at. Now you have to play with the pitch to get your speed at that point.
Yeah.
And once you find those two come in place, you pretty much have a good motor run every time. But even with that, you change altitude, you fly higher altitude, or you go at the sea level, or you go in Muncie, you go somewhere else. The weather conditions change a little bit. You fly in thinner air. Now you have to play with the nitro. I mean, there's so many variables. That's why I like, that's why I want to say that electric, because it's
right.
I can make my change in the next flight and be good to go and for the rest.
Yeah, that was like with the Stalker 76. We were trying to fly what everybody said, 4.25 pitch prop on that, and I'm up to 13 inches, and this thing would overheat, and it didn't fly good for Samantha, and she's like, it doesn't have any power and all this, and I'm messing with it with Venturi sizes and all that. I talked to Rich Oliver, and he says, yeah, you want at least a 6-pitch on that, and I end up going with a 6.5 pitch that Jeff Truxler had made for the Super Tiger 60. We put that on there. Now we're only running, I don't know, 7,200 RPM or whatever, and the plane just came to life. If it turned good, it had power up the butt, but yeah, we couldn't spin that. It did not like. It must be the difference in the timing. It did not like the higher RPM.
Yeah, because the motor, those IC motors, regardless of what you have, for a set Venturi, for a set compressor or timing or whatever, they only have one place where they are super happy, one RPM range. When you get a 2-4, and you get it consistently, you get it, and the motor is very happy. If you try to get it out of that range and move that range up or down or something like that, they're gonna just be all over the place, or they might run okay for a flight or two, but after that, they're gonna be very finicky and crazy, going nuts. That's with any motor. I mean, you pick any motor and you get a Norvell, for example. If you get a Norvell and you fly the Norvell try to fly the Norvell at 10,000 RPM, forget it.
That's one of my favorites there.
Yeah. You run that guy at 25,000 RPM and go like, woohoo, yes, love it.
Steve, power up the butt. I'm not sure we allow that kind of language here.
The other thing you might want to check, Al, and I don't know, and this is on that LA46 I have, John Tate made it. He calls it that tater bug motor. It likes a 12.5. That's what I found, a 2-bladed 12.5. And it really loves that one. But yeah, when they change that timing or whatever they do, Yeah, you really got to find the prop that motor loves.
I run that motor with a 10.5, 4.5.
Yeah. Well, I was, like I said, one day I was just leaving the needle setting alone and just, I brought like, yeah, of course, this is the Gardner setup. Yeah, different head, different liner and stuff. And I just bought the normal props I normally run, and then a carbon fiber prop that had very light pitch. And then I just said, let me try the 3-blade. And the 3-blade had the most pull to it. Like actually, it went as fast as a 4 or 5 lap time, and then I went another day to revisit it, to take all the information down. And then I said, well, let me open up the needle and slow it, see how it runs. And it loved it. When I got it, right in the 4-stroking range, it would break real nice. You would hear it break, but the plane would not really speed up.
Yeah.
I'm really
You can
happy.
also try a 2-blade prop. You can also try a 2-blade prop with a bigger diameter. It's load. You're talking about the load that you put on the motor. Now, whatever pitch you have over there, say you have a 5-inch pitch or whatever it is, 6,
Right.
If you put the same pitch or bigger diameter, we're probably going to run the same. Probably
Right.
even try that. See if it works. It's all about load. You're gonna know if you have too much load, then it's gonna stay in a 4-cycle, and no matter what you do with the plane, it's gonna stay in a 4-cycle. If you don't have enough load, it's gonna break in a 2-cycle, and it's gonna stay there for the rest of the loops or whatever you're doing, right? And then it's gonna, once you go on level lap, it's gonna take it a while to finally settle in and go back to the 4-cycle. That's not enough load. So just by flying the plane and listening to the motor, you can tell immediately if you have too much or not enough load on the motor. Right. And speed-wise, it's all about pitch. Speed is pitch, right? If it's too fast, you have too much pitch. If it's too slow, not enough pitch. So that's that. Diameter and load on the motor has to do with the way the motor runs. Pitch has to do with the way how fast it flies. So that's all there's to it. Yeah. So once you fly it and you're in the air, if it just flies 4-cycle all the time, it doesn't break in too much. In a 2-cycle where you need it or where you want it, too much load, right? You need a lighter prop, a smaller diameter, less blades, something, whatever.
Right.
I found out too with that 46 is that we set it up to run on 11.4 and spin the crap out of it. It used more fuel than when we went back to a 12.5 and a smaller Venturi.
I'm only using 4.5 ounces. The guys my friends, they can't believe it. They say, like, I can't understand why you're getting such great fuel mileage.
Killing the motor.
Yeah.
You are killing the motor. If you have a motor, let's say a 40 size, and you use less than 4 ounces of fuel for a 50, 5 ounces for a 66 ounces, pretty much like that. I'm not sure how much a 70 uses or a 90. I think they go down in the fuel consumption anyways.
Right.
But that's typically a 40 size motor uses about 4.5 ounces of fuel of flight. If you don't do that, if you don't go through that much fuel of flight, you're probably burning that engine.
Well, I had the 40 in there, and I was using the 40 I had in there. I was using every bit of 4.5 ounces. Like I would just have a few laps after the pattern.
The fuel usage.
But then when I went to the 46 with running in a 4-stroke with the Gardner piston liner, I'm getting better fuel mileage than I did with the stock LA40.
Yeah, well, I think what happens is that it's kind of like with an electric motor. When you try to spin that smaller pitch faster, with the timing the way it is, it generates more heat.
Mm-hmm.
And you're pushing a lot of fuel to pick up a minimal amount of RPM. And it's like that tater bug motor that runs on 3.5 ounces. When it lands, it's nice and cool. But it has something to do with how we did the port timing and all that. It doesn't use fuel. And I was like, wow, but the Stalker 40s, about 3.25 ounces for the whole pattern.
Yeah.
Wow. they come there and you put that on there, but they don't run the RPM, and I don't think that you're losing all that fuel to heat.
But yeah, but on the other hand, you were using a big diameter prop with a very high pitch, low RPM, which is very efficient.
Yeah.
A lot of less power. So power is fuel used. The more fuel you use, the more power you generate.
Right.
It's like I mean, you can burn 1 gram of fuel and gives you so much energy, or you can burn a kilogram of fuel, 16 ounces of fuel, whatever, and then it's going to get a lot more energy. It just makes sense, right? So the more fuel you burn, the more power you generate.
But in my case, between the LA40 and the LE6, I used the same exact muffler, same exact machinery, same exact low plug, spray bar. Everything was exactly the same. The only difference was the engine, and then I used the 3-blade prop too, like you said.
Yeah. By having more torque or whatever that different port timing does, you can run a bigger prop, like he says, more efficient. You use less fuel and
right.
Man, Steve, you might have just solved the problem for me, because with my John Tate 40, I told you I used 10.5, 4.5.
Yeah.
And I can't get a pattern. I can barely get a pattern out of 4.5 ounces. And I'm thinking maybe if I up that to a 12.4, 12.5, maybe that'll solve my fuel problem.
Try the 5
on your motor.
Pardon me?
It all depends on his motor.
Yeah.
Because if the motor is going to run where it's not happy, you're not going to get the motor run. So you get your motor run, then you find out how much fuel you use, and then you find out what kind of fuel tank size you need in that order. Because right now, if you have a fuel tank and you have 3 ounces, going to say, I'm going to have to use 3 ounces no matter what per flight, you already shut yourself in a foot, because whatever you're trying to do, it's just not going to be optimum at all.
Yeah, try a higher pitch blade on that motor, Rusty. And
I will.
Because, he told me what to run, and I didn't have any, so I ran what I normally ran.
Yeah.
And it didn't run. Once I went to the prop he said to use, all the problems went away, and that is absolutely the best running IC motor we have.
I'll look in the box. He might have put a note in there recommending a prop too. I just have always used a 10.5, 4.5 with my 40s, and so that's what I put on it. But it runs out of gas.
We just have tornado warnings. I'm having tornado warnings here.
Oh my God! I knew you guys were going to get bad weather. I didn't think you were going to get tornadoes.
Yeah, the phone's here. You probably heard my phone going off before.
Yeah, you better check. Are you in the basement?
No, I'm upstairs.
Yeah, you better check real quick.
I better head downstairs.
Yeah, we hate to watch you on live, whatever we're on, just fly away.
Yeah, right.
YouTube.
Al flying without his models.
Yeah, right. I think. Let me see if I can. Yeah.
I didn't know y'all were in tornado country up there.
Pretty here.
Wow.
Mercy.
Nice.
Yeah.
Yeah, you're gonna have some hell of a weather. That's like where I grew up in the neighborhood.
You have to take shelter. There's a tornado coming.
Okay.
I gotta get off the chat.
Oh, man, it got you out of the car? Yeah, go in the basement. Yeah.
When I was a kid, my mom and dad bought a house, and the week before we moved in, it was right after they closed on it or whatever. They had so many, maybe it was 2 weeks before we moved in. A tornado went through there, tore the neighborhood up. But luckily, the house they bought didn't get hurt. It just blew a bunch of trees down and stuff. And here 3 years ago, a tornado went right back through the same. So they called that Tornado Alley. Over 100-some years, so many came through. This tornado took out 200 and some trees. It was the park that we had. I grew up in, that these trees were They figure 150 years old. There wasn't one left.
Oh my God, hello.
Hey,
Hey.
You better drag him down to the basement. We're telling him we don't want to see him flying away on live TV.
He'll be flying away. And but you won't have a line this time, you know? He'll just
Get my handle. Get my lines and handle. I'll attach it to your belt. All right, they're all loading up for Rory. All right, guys, I'm going to sign off.
Okay.
We'll be on for a bit. Yeah, come back, probably only in the last 15, 20 minutes.
Okay.
All right, Al, be safe.
Yeah, thanks. Have a great weekend.
Right.
See you later. All right, it's down to us diehards now.
How many more of them airplanes are, before you get your molds back, are they going to make or whatever? They going to try some more things or?
I mean, we pretty much done trying. The main thing we want to try right now is painting a mold.
Oh, okay.
That's #1 focus.
Now are you gonna go up there and try to do it, or are they bringing them back down to you, or?
No, I'm gonna go down there and make the next one. I'm gonna take a week off work and I'll go there and make a plane and bring it back home with me.
When are you? Do you have any idea when you're gonna go?
No.
Let me know. I'd take a day off or so just to kind of come down there and see how you do it and stuff. Drive over.
Yeah, well, you have to stay at least 2-3 days to see more of what we do over there.
Yeah, I could even do that, but I'd like to see how it all does. Now, is that in Aurora there, right where Chris lives and stuff?
Yes.
Oh, okay.
Yeah.
Yeah, I'd like to come see it. Chris was telling me about it and stuff like that. I don't know if he's made himself one yet or not. Chris has made him an airplane.
Chris is doing his own stuff. I think he built a Junar, but I'm not sure.
Yeah, he was trying something different, but he was telling us about that airplane when we were there in France.
Mm-hmm.
About how light it is and all that kind of stuff.
Yeah. I wish I could just send it to somebody that knows what they're doing and maybe get a little bit better trimming on it. Chris changed the setup that I had in the nets and stuff like that. So when I got my hands back on the plane, it was just unflyable.
Too sensitive, or?
It was crazy sensitive.
Yeah, see, he set up Samantha's airplane, and we had to drop down one spacing in the handle for her.
I see. Yeah, to me it was unflyable. So
if you have Derek Berry trim it, it'll even be worse.
Mm-hmm.
Derek Berry flies such a sensitive airplane. He trimmed Samantha's airplane, and she's like, "I'm gonna crash this thing."
She fly with a really wide line spacing.
Wide line spacing and really super tail heavy.
Mm-hmm.
And I mean, you can do a loop. If you think about moving your hand, that thing will loop. That's how he does such square.
That's too sensitive for me.
That's how he can take that airplane and go bang. It takes nothing to bang that over.
Mm-hmm. Yeah. Well, FCG facilitates that.
Yeah. That's like Samantha when we're trimming an airplane. She always does it on the top one. She'll come up and see how square she can make this one first. How sensitive before, then she'll come up and pop it over this way before she's flying it at the ground and doing a turn.
Mm-hmm.
And she'll get that thing trimmed to where, I call it turning it inside out. She can make it so, but she's still not as aft CG as what Chris is, especially not Eric.
Yeah. Well, what I have in my plane right now is as a setup. I try to I play with the expo in it, so I have a soft center And when I do the loops, they're nice and round and tracks nicely, level flight and stuff like that. They just tracks nicely, almost effortless, right?
Yeah.
But when I need to corner and I move my hand, I snap and it just like make my hand movement. Uh, it almost kind of disappears out of my sight, and then as I neutralize it, kind of just bam, just like a UFO almost, like being just
Yeah.
like it's here, it disappears, and I see it
Yeah.
over the next time. It's that fast.
Yeah. When I flew RC pattern, I could never fly Expo. I always thought that something was going wrong with the airplane in the center when it didn't move, and that I'd overturn.
Mm-hmm.
Once it's like, oh my God, then, but I had to have mine set up linear to where if it took, quarter inch of movement or inch of movement to get a square, then I knew that a quarter of that would get, a quarter of a turn or whatever we were doing. I had to make, but I could never use Expo. I tried and tried, and I had friends that loved it and they always used it, but I never could use Expo for some reason.
If you get your hands on this plane and try to fly it, you probably would see what I'm talking about, because it's easy to fly level, it's easy to fly another loop, and then when you ask of it to turn and corner, it will at the same time. So it has the best of both worlds. Like for example, if you turn a corner, you want to adjust a little bit after that, correct it or something like that. It's very easy to do because it has a soft center. But then when you hit it again and to make it turn, I mean it will turn. I mean, you ever did you see that video I put on my practice flight?
Yeah.
Did you see the turn on that?
Yeah. This is turning good. I know, like you said, the amount of deflection you're getting.
Mm-hmm.
That's the same way that Samantha kind of likes to fly an airplane.
Mm-hmm.
That when she gives it full up, that's a square turn.
Yes.
It doesn't, but she doesn't. A lot of people like even more than that. That the thing will, but they're trying to keep it out of the ground, and she doesn't make mistakes to where she can bang these and it's there.
Yeah.
And she doesn't overturn and stuff like that all the time. But I can't, I don't like to. Well, I can't fly control line airplanes. Is a big thing. I'm just a shitty flyer. You haven't been on here. I tell everybody that the ground is like 3 foot higher in Michigan than other parts of the United
States. Well, yeah, I have to retrain myself because this is a brand new experience. It's a brand new plane, so I cannot possibly. I would do it no justice by flying it the same way I was flying before.
Yeah,
because
it's too bad the time of year. I mean, if you could get up there with Bob Hunt, and he can really ring out an airplane and know what it does and the trimming and when he trims an airplane, it's like wingtip stuff. He may add a 16th of an ounce or a 32nd of an ounce of tip weight to adjust different things. And I watched him there that one time trimming on that new airplane of his, and it's like, oh my God, how tedious. Take a flight 16th of an inch, and he's like doing stuff. All right, and he's moving lead outs, he's doing this, and until he finally gets it. But it is, that's the same thing with Chris Rudd too. When he trims Samantha's airplane, it is a long, long process. So when you do one thing, it affects something else. And you do that, it affects something else. Until you get it to where, it's the best all around, I guess, would be what you're saying.
Yeah. I'm just like for now, I'm very happy with the way it responds to the input.
Yeah.
Okay. It tracks nicely, nice flats, nice everything. Loops are easy, and it's like when the loop is easy, you can do fine adjustments in the middle of the loop without the plane jumping all over the place and being so. If you use the typical control system that you have on any plane, you know, where you have the bell crank to the flaps to the elevator kind of thing, you pretty much stuck with a, you know, response. If you have a lot of response, like you said, the Derek Barry has, where the plane is so touchy, then your loops and stuff like that, it is just really hard to fly. Well, corner, but loops are very hard to fly. But to get the corner and the loops easy to be at the same time, you'd have to do something else.
Well, that one plane that Chris designed and Samantha flew, she said the one thing about it, it would really turn, but she said it would lock into a loop. That if she set, you know, she's seen the angle or whatever, it would fly. She had very little, had to readjust hardly any. So it could be a lot more sensitive just because it never changed. Or the other airplane, she was always put input in to try to keep it round.
Yeah.
Or this one,
you already have a lot of variation in input to it too. Yeah.
Yeah.
Well, so on the top, you lose up a lot of input, and you have to whale on it at the bottom.
Yeah.
Those are typically heavy planes with a very forward CG.
Yeah. The other thing is that with the Igor deal, it never really changed speed as much. You know, it didn't go flying fast here and then slows down. So now you got to add all this kind of input and stuff. That thing would change RPM and fly, and this you could hear the motor slow down, and it was just a constant speed to where it made it flew every part of that loop with the same input.
Yeah, that's a nice part of those accelerometers and active timers. That's the nice part of them.
Dorian, I could hear your engine when you would pull a hard corner. I could hear the engine waver on each corner a little bit, and I was wondering if that was part of the control system, making it the electronic control system making it do that.
Yes, and you can definitely hear it in the loops.
Yeah.
When the loops are just powering on the top and then come off on the bottom towards the bottom.
Yeah, you really hear hers on the downside. She likes a lot of deceleration or really back so it won't speed up. You can really crack that first bottom, and you can hear that. But we weren't putting in too much RPM going up, and that was a lot of the Chinese and the Germans were also, because they were watching her fly and said, "Hey, try this. Don't go with so much RPM. Constant this part, kill it on the down." And that's what we did, and she really liked it. We're still up there with the complete adjustment, but we're getting a whole lot closer to how she likes. But yeah, you could really hear the Chinese and the German guy there that when that thing went, you know, that motor was like, whoa, you know, you could really hear it come off on the downs. When you hit that bottom corner again, that thing it's there instantly.
This is what I'm talking about electric, because you have from full power to zero, you know, you have the full range to play with, versus in IC, you have a very narrow range to play with, wherever the engine likes it, and you're stuck with that.
Yeah, so that's what Rusty was kind of hearing when you can really hear it when you on the squares when you really
that was the first place I noticed it. I could hear it in the loops too, but mostly in the squares was where
mostly in the squares is that way. You can you hear it a lot in overheads if there's a lot of wind, because it won't let you wind up.
Yeah.
When you go downwind, you can hear that thing cut off and you hear it come back on where it plows into the wind.
God, that's the hardest part for me flying the IC is on a really windy day when you're coming on those straight down legs. It really accelerates, and you find yourself guessing at when to pull out and almost panicking.
Well, that's one thing about the very thick airfoil that the thick airfoil that the IC kind of loves is when you are overhead, when you're pulling initially and you're climbing all the way up to overhead, because the airfoil is so thick, the wind is pushing it from behind. It just shoots it over your head, right?
Yeah.
But as soon as you start to do your first half of the loop and you come into the wind, now that you have a huge parachute over there that breaks you down, and you lose so much speed over there, then becomes like an RC plane, right?
Yeah.
So that's the problem with it. Like, it's a compromise. We compromise because of the way the motor runs, and you want the 2.4 brake on an IC motor, but in order to do that, and you have a narrow range, and then you need a thick airfoil, and then if you have a thick airfoil now, now you have issues with the pattern, right?
Yeah. And that's something you really have to get used to with electric, is that when you fly into the wind, you don't got to grab a whole bunch of handle.
Mm-hmm.
It's like the airplane slows down, so you got to really, start putting handle in it to get it to turn, because it's not going very fast. Then when it goes by you and starts accelerating a lot less, because of the speed of the airplane, then the wing is more efficient and
yeah,
more lift and stuff. And it took Samantha a little bit to learn.
Yeah.
That it was a lot different, but she's finally come along. She said, she goes, I don't know if I could fly an IC motor anymore, because of getting ready for it to slow down and speed up. And
yeah. Well, for me, it's because I have the thinner airfoil on this plane. I mean, I have a 2.25 inch on the root and an inch and 1.3 inches on the tip. That's how much thickness I have on my airfoil. It's a cleaner aerodynamic. I don't have any issues like that. When I come overhead, it's not speeding up too much, or it's just kind of constant. As I start my overhead 8 and I'm coming into the wind, it just plows through it.
Yeah, I'll have to measure Samantha's, because I thought either her wing is 2 1/8. I think it's 2 1/8 at the root, and I forget what it is at the tip. But
I'm sorry. Did I say 2 1/4 on mine?
Yeah.
It's 2 1/8 on mine.
Well, okay. I think Samantha's is 2 1/8 also. That's that old Junar wing or whatever that. But it was made to fly in the wind, and she would have done so much better at the World Championships if we'd have had windy weather. I mean, that airplane in windy weather is just so good.
Yeah, y'all had unusually calm, didn't you?
Yeah, and I mean, everybody's like, and we have a real bad, a field here where she flies all the time. It's really, we knew it was turbulent, but everybody said that there in France, that field was so turbulent that why a lot of people didn't like to fly there. And even when we had the turbulent air, Samantha's like, this is so much better than our field. That our field is even worse with turbulence. But she got to where that airplane, I mean, it would fly in turbulent air so good. Like you're saying at Huntersville, when you're getting it and you come back out, it didn't change the airplane around. But in dead calm wind, it flies good in dead calm wind. But that's where we didn't actually go for the airplane that was, the best in calm wind or whatever. Because we did a shorter, wider, route and stuff like that, thinner. The thing it works marvelous in gusty, windy conditions. But, there's always a trade-off on how much you go for windy weather, how much you go for calm weather, or, perfect stuff.
Yeah. Yeah, and just I guess there are different things you can do.
I was thinking, like with yours, you could actually make different plug-in wings, that if you wanted them for like the perfect 5-mile-an-hour wind or whatever, or if you had something that was really windy and gusty, you could, shorten stuff up or whatever, and lengthen the cord and
I could probably add ballast to it in the wind.
And change it that way.
Yeah, change the weight. Yeah, change the weight. change the setup, the run on the motor, and everything else. So glider guys do that a lot. I mean, you're gonna see them when they fly in turbulent air and windy stuff. They add ballast to the plane. They make it heavier.
Oh, okay.
So it's gonna give them a little bit more speed, a little bit more penetration, and more stability in bumpy air.
Oh,
And
okay.
that's pretty much what I would use it for, just add ballast to it. Because I'm so light, I can probably add another 5 ounces to it and still not feel it. I mean, just yeah.
It's something you're gonna have to play with and write down and know what
Yes.
works best. And
yeah, that's why I'm saying, like, I'm baby steps right now in infancy when it comes to all these setups, and I'm still finding things out.
that's why
Back into it, I need to get more vigilant about taking notes.
Yeah, because look at David Fitzgerald. He's flown that airplane for 10 years.
Mm-hmm.
Yeah, he knows exactly what it does and what kind of weather, what kind of altitude. And I think that's why he's just so hard to beat. It's like he knows exactly what to do with that airplane.
Mm-hmm. Yeah, he knows it so well, and he's been flying the same plane over and over. That's why one of the reasons for which I'm saying, this plane I have right now, it's so good. I mean, it makes no sense to try something else or something new. And besides that, once you have something that's solid, it's so good. It's might as well just learn it and fine tune it and it well.
Yeah.
Yeah. It just yeah. I don't know what I have on my hands yet. Not even now. I mean, it's like it can be so much more different. We may end up with a different motor, with a different battery pack or whatever, by the time we're done with it. I want to test at least the 12-inch props that I have and start to test them.
Yeah. Well, the other thing is that if you look at like Randy Smith's airplanes, the SV11, the Vector, the Staris, he did little changes over a whole lot of years.
Mm-hmm. Yep.
And fine-tuned everything.
Yes. Yeah. Yeah. SV12 has just a little bit longer tail compared to SV11.
Right.
That's where I started actually, but for me, what make the biggest difference for me when I learn how to fly to get better? It's what I call get your shoes bigger so you have room to grow into them.
Yeah.
So if your plane will outperform you, you can grow up to the plane's performance only.
Right.
So if you have a shitty plane that you fight it all the time, well, guess what? You're gonna stay at that level because you have no room to grow. But if you give yourself room to grow, that's my first advice I have for anybody that just learn how to fly the pattern. I say, once you learn how to fly the pattern, you know how to fly all the maneuvers. Stop screwing around. Just get a nice ship, get an SV11, get something performing.
Yeah.
And you might play safe with it and higher bottoms and stuff like that, but the plane will perform. The plane will help you get better because its potential is so much higher than what you can do. Then you can also chase it and you can get better and better and better until you reach your potential. It's the same as the plane potential, at which you can stagnate over there and you're done. But having room to grow into, I mean, just like, it's crucial. I jumped from a twister-ish kind of plane to an Intrepid with a 46 VF on tune pipe on it, and I did not know how to fly the whole pattern. I wasn't very good at all the maneuvers, but within 4 weeks, about a month from that point, I knew how to fly the whole pattern. I was already flying the whole pattern. So, and the progression was just incredible from that point on.
Yeah.
But I had a plane because I made a change. All of a sudden the motor was running, from beginning to the end of the pattern, was consistent, was flying kind of the same every time, even though I didn't know how to set it or something like that, but I was pretty close enough to get the job done. The plane, the plane, it's an SV. I was Intrepid actually, and the plane would turn, would fly wherever. So from flying and worrying about the motor quitting and the plane breaking in half or something like that, my mindset was changing to where do I want to put this plane next?
Yeah.
So I was just focused on what do I want to do with it. I wasn't just all of that worrying and stuff like that. It was just out the window. I mean, just forget it. It was just like it was non-issue at that point. And I made such a tremendous progress by the time I went to my first contest. It was in Los Angeles, south of Los Angeles. I'm not sure, at the Whittier Marrows. No, not the Whittier Marrows. That's a little bit north of Los Angeles. But anyways, there was a contest where Bill Biles was having a contest south.
Is it
So
the
I went
Golden
over there.
State? Was it the Golden State Stunt Championships?
I'm not sure. It was a paved runway, a very nice place to go and fly. And I go over there at my first contest in the United States, flying. I had an Intrepid with me, with a 46 VF, flying in beginners for my first contest. And everybody was going like, what? The thing I couldn't return on the next day, we were flying classic and beginners in the first day, and I was flying all the other, the intermediate, advanced, and open next day. So I said, because it's my first contest in the United States, I just learned how to fly the pattern. I said, I'm going to just try my hand at the first contest at the beginner. So I flew the beginner pattern. And after that, I just completed the pattern. I put the reverse wing over. I've added the triangles, everything that was not the square eights and the vertical eights and hourglass and the four-leaf clover. And I added everything in there, at the end of the pattern. And I don't think I was too bad at it, anyways. I think I would have won intermediate easily.
Yeah.
So, and after I landed, the judges came to me and they go like, you don't belong here. You're done with beginner. But
Hey, you didn't know where you belonged. You had to start somewhere.
Yeah.
Well, a lot of it is, with anything like that, you got to trust your equipment and not have stuff that has a whole lot of bad habits and stuff like that when you're trying to learn. And, I know everybody's going to crash. They don't want to crash a real expensive airplane and stuff like that. But when I was shooting competitively all the time, my coach, is like, it's 90% the shooter, 10% the gun. You can't have a crappy gun. You have to have a gun that stuff's right. Like with the airplane, it has to be straight. It has to be light. It has to be rigid. And you got that, then you can build to a point to when then you can trimming how you like the engine to run, or with electrics if you want more this and less that. And that was like with shooting. Once I got 90% there, then I could trim the gun into me. Trigger pull and this and that and everything else that I liked.
Yeah, make it to suit your likes, whatever you like. Yeah.
Right, your reflexes. Not everybody has the same, the same reflexes. It was like with Samantha, she really has super fast reflexes, and we were taking a stopwatch, starting stopping, see how fast she could do it. I mean, she could just kill me on it. How fast she could do it. She could just push that thing twice so fast. And I'm trying, I got faster at it, but I never could beat her on how fast she can push the stopwatch. Start, stop. And we're taking it out, and everybody was trying. They're like, holy shit. How can you start and stop that stopwatch so fast? But she just has fast reflexes. There's probably people out there that could really beat her doing it. So you have a plane then that's going to fly to your reflexes.
Yeah, that's what I need to do. I need to retrain myself because on this plane, I have to give it a lot more, you know, I cannot say a lot more, but considerably more up and considerably more down. And I constantly find myself flying like the way I was flying before.
Yeah.
Where I'm just easing up, easing into the corner, just fly it like that, and I'm going like this instead of going like bam, you know, just like just kind of going slowly instead of going like wham, because that's about the timing on this one. It's just a lot faster. So I have to retrain myself because I find myself flying the same way I was flying it before. So that's my challenge right now, um, and that's because of the new plane. And it's just I just have to fly up to its level because otherwise I'm just uh, baby. Like if you watch those videos, in the first video when you saw my buddy flying it, he was babying the plane. I mean, he was really soft on the corners, soft on the turns and stuff like that. And he wasn't even trying hard, but still the plane was flying okay. And it was you would take like would corner and would fly. I mean, you could see a square, you could see a triangle, you could see the maneuvers, right? And and the second video when I was flying it on for practice, that's when I started to give it a little bit more input on squares, and you can tell that it squares pretty well. But I know I still have a lot in reserve over that. It is capable of so much more.
Well, it's like with Samantha flying on airplanes. It's like this ain't turning fast enough.
Mm-hmm.
It doesn't. She's like, it doesn't turn good. I said, I want to go up there. I want to see how tight a loop you can do.
Mm-hmm.
And she can just do this little teeny loop. I'm like, how is that not turning good enough? But it's something with how far she wants to move or how quick it reacts or something.
That's personal flying style and it's personal preference. And that's all in the handle spacing. I mean, it's like it's not a plane, and maybe she wants more handle spacing, so it has less put on the hand,
or a little more tail weight or nose weight or whatever we adjust it to. But yeah, that's like I try to tell her, it's not the plane won't turn. It's just we got to make it to turn like you want it to turn.
Mm-hmm.
That thing will, do it.
It doesn't change. Yeah, once you get the plane to track nicely in that little tiny loop and track after that, the plane is ready to turn, right?
Yeah.
What you have to do, like at that point, you don't need to mess with the plane trim or anything like that. You just have to change the handle spacing. Like, for example, if I would send my plane to you and you give it to Sammy, Sammy will have to get her own handle and probably start where I'm at and get a feel for it. And if she needs more, just change the handle. That's all. A handle neutral and a handle spacing. That's it. It's not the trim of the plane. The plane will, the plane can only max out its performance at a certain spot. But if you try to go past the maximum performance you can deliver, that actually you're decreasing the performance of the plane. Yeah. That's what you're talking about. It's a personal flying style, personal flying preference.
The only thing we do with handle spacing is that I don't let her go down below her fingers.
Mm-hmm.
It's got to be,
Why not?
You lose sensitivity when it's real close.
It's her hand. It's her flying style. If she needs it, give it to her.
But she flies better when, if instead of lowering the handle too far, put a little nose weight in it. Move the CG.
No.
So that
no.
Still have that same feeling.
No. Lower the handle. Leave the plane in its optimum performance. I had a friend of mine that one day I went to Chicago to see my dad, and on my way to the home city, I pulled over to this flying field where there was a nice club at the time, and they were flying a lot of control line. And one of the guys that was going to fly to the Nationals was flying his plane. He said, "Hey, you want to fly?" He said, "You want to fly the plane?" I said, "Yeah, sure, I'll fly the plane." So I flew the plane. The plane was very doggy, right? So what I started to do and help him out, because the plane was kind of heavy anyways, we started to add tail weight. and the plane started to turn to the point that was turning so well. He had to drop the control line, the spacing on a handle to match his flying style. I think you don't want to mess with the performance of the plane once you have the plane trimmed and set up and stuff like that. You want to do it at the handle, and it's no big deal. I mean, if you have to make the handle look like a combat handle that goes between your two fingers, and that's what you have to do to get to fly it to your preference. But you don't mess up with more nose weight, because you just take away performance from the plane. I kind of disagree with that. I mean, if she needs less spacing, less handle spacing, and she's happy with that, just give it. It's fine.
Yeah, but a lot of times it's when she's doing the less spacing, is that she's trying not to get it to like bounce coming out of a corner.
Uh-huh.
You know, so she's doing that.
Yeah, because it gives it less input with
Right.
less input. So that's
But a little nose
something
weight
else.
will fix the same thing. Just a little bit of nose weight will stop that from doing that bounce.
Which changes your lead out position. You change the way the plane responds, and you just soften the corner of the plane. And it's you have to retrim the plane basically for the new condition, and for something that you can do in a handle. So this is the problem. I think the problem is different, and the key to that is the fact that because she wants less spacing means she wants to cool off the plane. The plane is too fast for her, right? And probably she's just used to go in a corner, say this much, right? And this is the timing, 1, 2. When you plane flies 1, 2, the corner, right? And she goes like, well, because the spacing's to be my 1, 2 is my 1, 2, and so it goes past the vertical. I think she needs to adapt her flying style to the performance of the plane. I think that's more important. And if she needs to have the plane cooled off a little bit, that's fine, but it's like you fly to the maximum performance of the plane or to what you like.
Yeah.
And what gives you more points? What you like or the maximum performance of the plane? I mean, if the plane is capable of doing carve, turn, or you want to see this softy corner that looks almost like a loop with a little bit of itty bitty flats on it. And when the plane is capable of this, then you have to adapt your flying style like I'm doing right now with this plane. I know I have to do that. There's no way around it, because otherwise I do it no justice. And I'm still learning. Yes, I'm still learning. I'm scared of shit, of it. But I'm trying, and I think I'm, a little bit successful. You saw that video, right? You saw me going hard on it.
Are you flying with a hard point handle or a cable handle?
What's the difference?
Where the lines hook right onto a piece of steel or whatever, or you got a piece of cable running through your handle.
The cable is in front of my hand. It's one of those adjustable handles, but this is temporary only until I find something I really, really like. At which point, my preference would be to go to a flying handle. Maybe I'm gonna make my own handle with a carbon fiber plate and have just 2 holes that go exactly at the spacing that I like.
Yeah.
And I like the fact to have the longer cable that goes like this through the handle, because when I'm reeling in the lines, I usually do it from the plane and I leave the handle attached to the other side. And when you put the clip on, if you put the clip on the thin lines, it likes to kink them, bend them, mess them up.
Yeah, Chase. That's the way I put my clip on too, because I use a adjustable cable handle. But I'm thinking of switching to a hard point just because I believe it might give me a little bit more positive control without the springiness that the cable handle seems to introduce into the line action.
See, we always take off the handle and reel from the handle to the plane. Because just for the reason that we've had people hit the handle, or you drop it or something and it hits the ground and all your wires, you know, if you don't have that extra weight hanging out there on that reel. But we're different than everybody else. When we roll up, everybody looks at us weird because we roll up from the handle end instead of from. But Samantha likes that too, you know.
That's what I do too. I have the handle on a reel, and I go to the center of the circle. I drop it down, and now I have a nice weight over there that kind of holds my lines in place, and I just connect the other point to the plane, and I'm going with it. I mean, yeah, you can probably have another 10 people that are gonna do.
Yeah, however they want to do it, but everybody's like, you reel from the handle in, you take the handle off every time. I'm like, yeah, you know, and they're like, you can, you know, they'll have them marked black and red or something like that, so they know this always goes on the up or whatever. But we always put the lines on, and then just go from there. But I always make sure the lines are the exact. Doesn't matter if we flip a line; they're the exact same length. So it's just everything's adjusted on the handle for that kind of kind of thing.
I think that's what I did too on mine, but still, what I did on mine is I have green and red on mine. So
yeah, you know, you can do it that way and hook it to the plane too. We could, you know, we could take and put fingernail polish on one of them and say, okay, that's the up line.
Yeah. So what I do, I just take the clip off. I set the handle on the ground, and I just take, and then these are the ends. You see the ends?
That's the same way I roll mine up.
Yeah, that's how like 90s.
Same color code on a lead out wires.
See, I do it the opposite way.
Yeah.
I think 6 of one, half a dozen of the other. What I didn't like about the other way, this is the only one thing I didn't like about the other way. You have all this gap in here. And once you have to, when you clip the end of it, you have to put a piece of block of something or some
styrofoam. I get
something like
spongy styrofoam.
Yeah. Something, you know, and then you lose the styrofoam or something like that. With this, I don't have to put anything because the handle itself wants to spread out and it just stays there.
Yeah.
It doesn't go anywhere. So, and the lines are still inside. That's the only reason why I did. Yeah. And I like these longer wires because when I put the clip over here, you see how they go inside?
Yeah, it doesn't chafe on your flying lines.
So they're not on the flying lines. They're on these guys. And because they're so rigid, you know, kind of stays nicely. And I go like this and I just drop it in my pocket, in my toolbox. And
I'll show you once real quick how I do it. It doesn't really matter.
But I learned just before I got grounded, I learned what you're telling us, Doran, is that once the plane's in trim and I'm having trouble with something, to use a handle adjustment, and I ended up offsetting my lines from the handle so that they're, you know, more this way when I pull it rather than center.
Why would you do that?
Distance from the end. And I cured my porpoising bottoms by doing that. And I actually, when I fly backwards. This is up and this is down, up, down. And so I was over controlling, trying to pull out on the bottoms. And so I was, you know, porpoising like that, but I made it more sensitive so I didn't have to work so hard, and actually making it more sensitive so that I didn't have to move my hand as much, cured my porpoising. And that was just by offsetting the lines this way.
I think by, imagine this, if you have, okay, let me see that.
See, right,
the way I was holding it.
Oh, I see that. So you put a clip through that stuff, and okay.
Yeah, these clips will hook on the airplane.
Uh-huh.
Let me click on you there, Steve. Okay. Yeah.
It reels up really nice and clean.
Mm-hmm. Got it.
And then all you do is that when you roll it up, I just take and pull on that. And once I pull on it,
Mm-hmm.
the lines are tight and they don't ever come out of the thing.
Okay.
But yeah, that's
Good.
but that's just the way I've done it ever since I was a kid.
It works. It works.
And you just put it over the clip.
Mm-hmm. Okay.
But otherwise, yeah, people just hang them and then they try to clip it over and they'll actually the eyelets will slide out from under and everything goes up. But
oh yeah,
that just it holds them all in there. And
mm-hmm.
I stack them in the box, like so. How many sets of lines we take,
Yeah.
and we can mark on there what lines for what handle and.
Yeah. Rusty, what I'm gonna say about that? Say this is your handle here. If your lines are below, you just pull your hand up, right? Like you want to hold some up elevator. If the lines are high, it wants to go down because the plane puts the pressure in the center of the lines, right? If the lines are here, you have even pressure, right?
Right.
What's the misconception here? People think like, oh, the plane turns more up or down, so I need to move this line up or this line down to get equal turn, which is a complete BS. It's never going to happen, because what the bell clamp sees, it sees the angular deflection, how much angle you create from here to here, right?
Mm-hmm.
And because you're creating that angle, you can create that difference in distance top to bottom, right? So it doesn't matter where the spacing is, it's over there or over there. It's with the same angle, the same deflection is on your plane, on your flight surface. So it really means nothing. What you want to do is probably your problem. It's your neutral point. It's not correct, because if you have the lines in your hand, centered on your hand, and have nice even pull, right? You have no tendency, if your lines are high, you want to do this all the time because the plane is pulling on your hand. Make sense?
Yes,
okay.
You're right.
If they are low, they want to do this opposite all the time, right? Okay.
Yeah.
So if your lines are neutral and you pull out and your plane tends to always go down or always go up, and if you only invert it, it's the vice versa, then that's your neutral point. You have to change the neutral point to get it even. So I think that's where the problem is.
That's going to be one of the first things I need to take a look
so
at.
if you look at the pencil, right?
Yeah.
And I have a point here. If I move it here, this angle, you look at the distance here. That's what the bell crank is.
Yes. Right.
Okay. Now it doesn't matter if I put this pencil high, low, in or out. As long as I deflect the same distance, the same angle, it doesn't matter what it is. It's the same distance over here between your two lines. Make sense?
Yeah, you're right.
Neutral is it doesn't matter what it is. The angle, you go from this angle to that angle. You can go from this angle to the same angle over there, or from this angle to the same angle over here. It really doesn't matter, right? It's your neutral point. So probably what you are seeing over there, I'm just guessing, when you do an inside square and you pull up, if you pull up and it goes down, now if you do an outside square, you pull out and go up, it's going to be always opposite, right? That's because the neutral point is not where it should be.
Yeah.
That's what I'm thinking. But, a lot of people say, oh, I'm going to make this longer here and leave this up over there, and I'm going to get more downturn, more. It's not true. It's actually, you're faking yourself, because what you're doing, you have more pressure. Let's say this is neutral. You have a line here, right?
Yep.
You take this line and you drop it down, right? What happens, you just move your center of pull a little bit low, so you have a little bit of up tendency, right? So you already built in some up in your plane, and it may feel like the plane has more, may turn better up now than down, right?
Yeah.
But that's because you always have this into your hand, right?
Mm-hmm.
That's what's actually going over there. So I think your line should be balanced in your hand, and you shouldn't have the lines here or there. You should be centered in your hand so they pull equally. So now I have a nice control on your hand on up and on down, right? And these lines go straight to the plane. Now, if the plane turns too much inside and outside, that's the problem. It's not over there. It's in a position on a bell crank in a plane.
I'm going to have to think hard about that when I get back out. That's the first thing I need to work on.
Yeah.
One thing is that it's kind of like the trim on the airplane. We'll move her lead outs. Because she says it's turning one way more than the other or whatever.
It's not over there. It's on your push rod from your flaps.
Right. But it's kind of a quick deal to kind of find out what you want to do. And then go back to neutral spacing again. We can test things. Say I want a little bit more down in it. A little more up there.
It's not there. It's like if you want more down, you have to make. Okay, it's all geometry, right? It's geometry in your position of your neutral on your bell crank versus the neutral on the flaps, right? You know
what, Mike? There's something else that I might be introducing into my action is I hold the handle like this, so I'll wait till good Doran gets back and show. But so for me, this is up, and for me, this is down. Now, look at what else I'm doing, Doran. This complicates things even more. Is I hold the handle like this, over and under. Okay, so this is up, and I use my elbow for down. I probably.
It's because your wrist action, right? Because your wrist action, you have.
That's my total wrist action I've got right there.
Yeah, maybe with that you may wanna. You're kind of like me. See, I don't have much up, but I have lots of down. So for me, my neutral should be somewhere over here, somewhere in the middle of this range.
Right.
Whatever your range is, somewhere in the middle.
Yeah. Find neutral and then maybe get a wider spaced handle to.
It depends on what the plane is doing and what you're doing there.
Yeah.
So this is the typical bell crank, right? Okay.
Yeah.
Typical bell crank, right?
Yeah.
And it moves on a circular motion. This is the way the flaps push rod is moving in a bell crank, right?
Right.
All right. Now, if you put it in a neutral, it looks like this, right?
Yes.
And you're gonna have over there. Now, if you're playing, okay, if you change the neutral to about here, okay, see the new point?
Yeah.
Okay.
Yeah.
For the same angle deflection, say I'm gonna make it pretty large. See the center point? You move the same angle left and right, but because it's biased in one direction, you see how much less deflection you have on here versus the other side?
Yep, sure do.
Okay, so this is this application point over here gives you more or less flap elevator movement, right? So long story short, by biasing this neutral point, that's what gives you equal turn inside and outside. If your plane goes too much inside, too much outside, you want to bias it here. Okay, and it doesn't matter if you bias the whole bell crank, right?
Right.
If your whole bell crank is like that, it's also fine. Same thing is achieved.
Yeah.
Yeah, exactly.
So, and what I was saying before, I'm not sure if you catch that. It's at the handle. Say this is your handle, right? Your application point. This is the line, a line here, a line over there, right?
I got you.
If you deflect the handle in one direction or the other one, for that matter, you have this much of movement between the two lines, right?
Yeah.
Okay. Now, I can take this and move it up and down. This is my handle here. I'm holding the handle. These are the lines points, right? I can move it anywhere for the same angle distance. Guess what? You still have the same distance that the plane is actually seeing. Make sense?
Yeah.
Yeah.
By moving them up, however, by moving them up, it's going to try to pull down my hand because the center of force is right here in the middle, right?
Mm-hmm.
Because it's above my hand, it wants to do this all the time, right?
Yeah.
If they're below, it wants to do opposite. It may feel like you have more up or down, but in actuality, you still give it the same input for the same angle, regardless where they're at. It's kind of false feeling.
You will get an arm effect on that, though.
Yes.
It'll feel.
You're probably going to find out, like, if you put them above, you're going to feel the muscles underneath. It goes like, if you put a flight and it pulls real hard on you, you're going to feel these muscles. Now, if you put them above, you're going to feel these muscles on top. I mean, it depends which way you mess it up. I think you get them nice and centered on your hand. That feels good. If you have the plane turning more on the inside or less on the outside or whatever, it is, and you definitely want to you want to have a close look at that push rod from the bell crank to the
See, and that's why with it's so much easier to adjust a profile because you can get to that bell crank.
Mm-hmm.
If you got threaded ends on it or whatever, you can, or some way to adjust it, you can adjust that. That's why with a full fuse, you got to have a door or something or like with yours, you can do it right through adjust your bell crank.
Easily, yes.
You got to have some way to get in there to adjust that.
Yeah.
And you find that people that build a full fuse and they can't adjust anything, they're then trying to do it with the handle.
Yeah, they're just painting themselves in a corner. Yes, like I did myself with the landing gear, but that's a little easier to fix. But yeah, I mean, so I think it's a misconception trying to get one line up, one low, just to do that. It just doesn't make any sense, because for the same angle of deflection, you still get the same exact input on the other side. And the beauty of the bell crank, you can bias it at the bell crank. You know why? Where was it? Let's see. Yeah. The bell crank at the center here, if you bias the bell crank a little bit like that, because you have so much like 4 inches that have a long hand over here, still symmetric. Make sense?
Yeah.
It is, yeah. Exactly. Yeah, I see what you're saying.
It's still symmetric. For whatever, if your zero position, even if it's biased a little bit, it's still symmetric. Kind of, but it's not perfect, but it's still kind of symmetric anyways.
Yeah.
But, if you keep it in neutral and then you can bias it over here a little bit on on an application point. So that's kind of what I'm trying to say here.
Well, that's like, with Samantha on her handles. Actually, this point here and here are the furthest out. It actually is concave because when she flies her level lap, she only uses her pointer finger and pinky finger to fly level laps. We'll either squeeze the one or the other.
Yeah.
Just to give it enough to move that, when she's flying inverted or upright.
Yeah.
So most handles are made to where the centers are out and your other fingers are, they make it convex instead of concave. And
that's a matter of grip. I mean, whatever like for your grip. When I was in Romania, there was a guy over there that used gypsum to make his handles. It's the same material that they use for making castings when your hand breaks. So he would put gypsum, and then some of that was called some Band-Aid, the white stuff, and he would just hold it in his hand. And he would form the handle to his own hand.
Yeah.
I mean, you couldn't use his handle or something like that, but to his handle, it was just perfect fit, and it was very comfortable and all the stuff. So many ways of doing this stuff.
Yeah, it depends on how you want to fly. If you want it solid in your hand, or if you want it to, she likes
personal preference. Yes.
Yeah.
I like to use the first row of knuckles, fingertip control almost, instead of a death grip.
Well, that's like Samantha's. Is when if you watch, you see her out there, you watch her fingers. They'll be here on straight and level. Then when she goes to other things, she brings that handle back in. So she's doing little teeny things here, but it's probably like exponential. She's using her fingers to fine tune, and then she grips that handle back to hit the hard stuff.
Yeah.
To where she may really like an exponential.
Yeah.
Where, she wasn't flying off the fingertips for one thing and re-gripping the handle for others. But she says
I really like my system right now. I mean, just like it's when I do loops, they track nicely. They're easy to fly. It's you don't go crazy, right? See, the thing is, like when you have the classical system where it goes from bell crank to flaps to elevator, right? You are kind of stuck. If you want to have a very hard corner, you want to have to make the system very sensitive, right?
Yeah.
But what does that do? In your level lap, you have a hard time. You have to be very careful when you do level laps. You have to be very careful when you do loops, right? But what if you have a very easy time doing level laps and loops, and also a very easy time making the plane turn?
Yeah.
And that's got a YouTuber named JP that's chiming in on this too. He says, think about people like Paul and Howard set their CG mathematically and then never touch it. They only use the handle adjustments and let the plane fly correctly, and moving the lines up or down from center doesn't change the angle of deflection. That's what you're telling me. Correct, but does change how quickly you get that angle in one direction or another, which does have a benefit sometimes. I guess that's what I was. Yeah, that's kind of what I was seeing.
If you had a handle that was this big, with lines out there, take very little pressure to change.
Yeah.
You got them in close. You got to push harder.
Yeah.
You got arm to figure in there to on torque.
It's a trade-off. That is a trade-off on a classical system between sensitivity versus ease of flying, right?
Yeah.
So when I was flying that kind of system, for my personal preference was I have to really push it in a corner to make the plane corner, right?
Yeah.
So which made it very soft in the center, still soft in the center. It was easy to fly level, easy to fly loops and stuff like that. But if I want to corner, I had to just wail on it, just really wail on it. And because I had the smaller spacing on a handle, then the plane would not really stall or something like that. But But on the other hand, I was flying Ken Tyser's plane, and I couldn't fly the plane. It was so touchy for me. It scared the shit out of me.
Yeah.
Oh, pardon my French. But it scared me. I couldn't fly it. I was afraid of doing anything with it because it was so sensitive. Uh, I just prefer opposite end of the spectrum, and Tyser preferred this super touchy, super sensitive setup. But it's a matter of personal preference. As far as goes with the CG, um, I'm not sure mathematically it's the correct way of doing it. You have to try everything and see what you like, what the plane likes most. But most likely is that I'll set the CG and push it as far back as until the plane is losing tracking. It starts
That's
to
that's when that's how I found it
yeah.
too.
Yes. And if I see the plane started to hunt over there, then I move it back a little bit forward.
Yeah.
And that's kind of the aft position of a CG. And then what you do over there, what I like to do after that, obviously the plane is very feisty and wants to jump in the corners like crazy, right? But what you do at that point, you just close your handle spacing to regain your flying style. And by doing that, you have a plane that's very responsive in the corners, um, and because of the CG is so close to the neutral point, the neutral CG, you have a plane that kind of like it stays in a maneuver, right?
Yeah.
If you do a loop, you give it a loop input, right, and you hold it there and kind of follow the plane. The plane it just kind of rolls and it just follows and grooves into that loop. If you have a plane with a very forward CG, what you're going to find out, you're going to give a lot of input on the bottom, you ease up, almost go neutral on the top, and then you start to add input more and more on the bottom and less on the top and more on the bottom and less on the top and go through this cyclical kind of style of input where and it's hard to hold the plane in a position like that because you're constantly controlling and chasing that loop. One other thing that happens when you have a forward CG, you need a lot of deflection control surfaces to make the plane move and do anything in the first place, and you to loop or turn or corner. And that creates a lot of drag, and a lot of drag slows the plane down. So which means after you corner, you lose so much momentum, so much energy that it's kind of hard to get to the next corner and hit it again. Like for example, in the horizontal A, which is corner after corner after corner after corner. As the CG goes backwards, you have very little deflection on the control surfaces. The plane maintains energy and plows through and goes to the next corner without losing much speed or anything, and tracks and plows and goes. And even on a light plane, I think that's practical. Now, a light plane, a super light plane, you can afford the forward CG because the plane was going to turn anyways, and it was going to make it track. But if you build heavy, then aft CG is almost a requirement.
Yeah.
So it depends. You might have a Paul Walker or Howard Rush or whoever that calculate their CGs, but if they build that plane to the perfect weight, might work, right? But if they plane that they are building that plane on a heavy weight, then it's completely different story.
Yeah.
And like I was saying, like the guy in Chicago, right? I went over there. We started to add tail weight, and there were two people flying on a field at the same time. One was flying a Legacy 60 with a tune pipe setup and stuff like that, much lighter plane for sure. And that plane was just turning nice and cornering and was flying nice. However, this heavy plane that we were just adding aft CG, well, guess what? By the time we were done, we are just trying, almost getting to that hunting point, and we didn't even find it. I mean, we could probably go even more FCG. We got to a place where the plane would just bam, we just turn, carve, and go, and it was unbelievable because it was a very heavy plane. It was a 70-ounce plane, and that plane was cornering better than the light plane.
Mm-hmm.
And still, because we started to use less deflection, and it was not doggy anymore. I almost crashed it, by the way. but trying to get used to it, I said, man, this plane doesn't corner at all. So we started to put little fuel tanks, like 2 ounces of fuel, and add tail weight, and just try to do that, and you just keep pushing it, and by the time we got done with it, he had to close in his handle spacing because the plane was so touchy.
Yeah.
But as he closing up this handle spacing, goes back into his flying style. Yeah, at this point, the plane would corner, would turn, would just go wherever you put it. And it was a heavy plane. So I'm not sure, I think you have to set the CG for the plane.
Yeah, one of the other things Samantha does is that she doesn't like a plane that flies neutral.
Uh-huh.
She always wants input.
Mm-hmm.
And I believe she has a little bit of, the airplane wants to go up. She wants to hold a little down in it because for landings, that she has to fly the airplane to the ground.
Okay, yeah. There are different planes at different planes. For example, for myself, I found out in my plane what I want to do. I don't want to fly down. I want to put my fuselage perfectly level to the ground, and the plane will just glide itself in. And just before I touch down, I add a little bit of up and to slow down the descent for the final touchdown, and it just grooves in and lands.
Yeah.
Just fine. But yeah, it's you can do that. But in windy situations, I like to fly high in windy situations, and put it on a glide slope just exactly so I touch down downwind.
Yes, she flies hers to the ground because she said that if it just sits there and kind of glides in, anytime you get a little gust of wind or whatever, it'll move the airplane.
That's because you have a forward CG. A neutral plane, when a gust of wind or something like it doesn't give a rat's ass. It's just going to continue the same. A forward okay, think about this. Okay, as the CG moves forward, you have to have some up control to stop it from nosing in, right? So because you have this up control into your plane, when the wind comes in, it sees that up control and amplifies it. Okay. If the CG is kind of aft and neutral, you don't have none of that, right? And when the wind comes in and blows through your plane, it doesn't care. It just continues on the same path because it has no, that's the same thing like people that, when plane are, some people have planes that are hunting. What they do, they put a little incidence on the elevator, or they give it some up, some down, something, but they don't have things in neutral, right? Long story short, but they stress the system, right? One pushes one way, one pushes the other way just to hold it straight, right? Kind of like that. As soon as wind comes and sees that deflection over there, goes like, this overpowers the other one and starts to do funny things. But you can see this in gliders, how people are setting up their gliders, because some people are setting them perfectly neutral, right?
Yeah.
They have the CG right at that neutral point, and they love it there. And unless if they put the glider with the nose down, it's going to stay there. It's going to plow. It's going to keep accelerating, but it's not going to do any pulling up or tucking or something like that. If the CG is forward, as the glider increases in speed, it's going to pull out, right? With a neutral CG, It stays there. It will not do anything unless
Yeah.
you command it to do something else.
Well,
I usually look for what mine does as soon as the engine cuts off, and if it goes nose up or nose down when the power cuts, then I'll adjust the CG so that it stays exactly level when the motor cuts.
Yeah. Nose up, it's a sign of forward CG. Nose down is a sign of aft CG. So that's all there's to it.
Yeah.
But usually aft CG and the tuxing is increases in speed.
but you
And
could
a lot
you
of
could
that.
have the engine thrust off too. The engine thrust is down a little bit
Uh-huh.
when you have power. When the power is cut, it's no longer trying to pull the front of that airplane down.
Mm-hmm.
Steve McBride just, oh, wait a minute. Which Steve am I clicking on? I was clicking on the wrong Steve. Hang on, Steve McBride. There we go. You got here. Well, hang on. Click.
That was like with pattern airplanes. A lot of people would put right thrust in it, a little bit of right thrust, a little bit of down.
Mm-hmm.
But when you pull the nose up, you don't get as much prop effect on it.
Mm-hmm.
But when you cut the engine down, the nose will rise on the airplane.
Mm-hmm.
There you go, Steve.
Because you don't have
that's the stress I'm talking about. Yeah, it's always stress because the motor always pulls down and out, right?
Yeah.
And all the trim controls are opposite of that. And then as soon as the motor stops, now they become effective, and the plane wants to go in that direction.
Right. Exactly.
So it just makes sense, right?
Yeah.
Hey guys, we gotta call it. It's getting kind of
1:11. After 1 o'clock. I thought Al might come back in, but he might have lost his. Who knows? He may have lost power.
Yes, his roof might have blown off or something. Who knows? I hope not.
Well, usually here when we get a bad storm, it's not that my house gets destroyed. The power goes out or the internet goes out.
Yeah.
And it's like, house is fine, but you can't do nothing.
How you doing tonight, Stephen?
Where's Samantha? She doesn't show up on this chit chats.
I was gonna call her tonight. She's at her dorm doing homework tonight, I guess. She has these study groups and stuff she does. She's supposed to be home tomorrow, so I don't know. She really accelerates in math and all that kind of stuff. It's actually the study groups are in for the nursing part of it. On whatever they do, they're going over laws and part B, part A, and how this works and that works, and so yeah, they had a study group tonight, so she stayed up to the dorm.
Got it. Yeah.
Okay, guys, I got to call it a night.
All right.
But we had a good one tonight. Thanks everybody for coming in. And now I got some more. Now I got some more handle.
For a minute after.
All right. Good night, guys.
Hey,
all right, take it easy.
You can stay on once Rusty leaves a minute if you want to.
Yeah, y'all can stay. Y'all don't have to quit. Just when I sign off, it'll quit broadcasting to YouTube. But y'all can still stay and talk. Where'd McBride go? He just left, I guess.
Yeah, he thought we were all kicking off real quick.
Okay. Well, anyway, all you YouTubers over there, and appreciate y'all coming in. We had some good stuff over there, and all y'all, thanks for coming in and supporting the show for me. And y'all have a great weekend, and we'll see you on Monday. All right. Take it easy. Rusty. All right. Good night, Steve.
Yeah.
Looks like Doran took off.
He didn't realize we can stay on either, so that's fine. Take it easy.
All right. Good night.
Night.